After covering variables, operators, and all these core basics that you need to know in JavaScript, and actually in most programming languages, there is another important block or set of features which you will also need in basically any programming language you're going to learn, JavaScript included, and that would be control structures. Now that's kind of a strange term. What does control structures mean? It means that when you're writing code, you don't always want to execute exactly the same code top to bottom. Sometimes you have some condition that should be met for some code to be executed and execute some other code if the condition is not met, or you need to repeat some code execution. And instead of writing every cycle on your own, you can use some built-in features built into JavaScript to run through a code snippet multiple times until some condition is met or until some data is exhausted. So that's exactly what we'll have a look at in this module. To be precise, we'll have a look at conditional statements, if statements. You might have heard about if statements if you worked with some other programming language in the past. And we'll also have a look at conditional expressions. We'll therefore also have a look at another very important related topic, and that would be Boolean values and operators that help you generate Boolean values, which turn out to be rather important in if statements and conditional expressions. And we'll also have a look at loops and how you can run the same code with different data maybe multiple times with help of the many loops that are available in JavaScript. Last but not least, after having a look at loops, we'll also dive into error handling, and that will be different from what you learned in the debugging section, as you will learn. Here I'm talking about errors which you can't avoid that might happen in your program as it executes, and how you can then react to them and what you can do to still fail gracefully, maybe show an error message to the user, or even fall back and make sure that your program works even though an error occurred. So these are all very important control structures, and with that, let's dive right into them. I want to start with conditional code execution, which is super important. For one, there are quite a lot, of cases, of scenarios, which you couldn't really solve or couldn't really handle without the availability of conditional code execution, so without features that help you run code based on certain conditions. The app we built thus far could be built without conditional code, but that's not the case for all apps. And in addition, even if you can build an app without conditional code execution, like our basic calculator, you can still often write cleaner code, shorter code, if you can run certain parts of your code conditionally. Now, what does conditional code execution mean? Imagine that you have a function, and conditional code execution is not just available inside of functions, by the way, but consider that you have a function, and in there you have two code snippets that you could execute. For example, you either add two numbers or you subtract two numbers. You do that in the same function, and of course you could write two separate functions, but even then you might want to call one of the two functions based on some condition. And that's exactly what conditional code execution is about. You might have some program where you either want to run option A, so want to add two numbers, or you want to subtract two numbers. So you have some condition that needs to be met, and for this you can use a so-called if statement. If statements are a core construct not just in JavaScript, but actually in any programming language you can learn. Now, if statements require conditions. You specify a condition that must be met. And a condition is in the end just a Boolean value. You remember that strange Booleans part I mentioned earlier in the course? Well, that's becoming important right now. This was this special kind of value which could only be true or false. But that's exactly what you need in a condition, because a condition executes code A if it's true or code B if it's false. Now, since a condition in an if statement wants in the end just true or false, you can always pass in a variable that holds true or false into that condition part. So you can always add if and then just check that variable and the value in there. That is possible, but you will not always have a variable that holds true or false. You will need to create that, and more often than not, you'll work with different kinds of data. Let's say you have some user input, which is a string, or you're working with some numbers, the result of a calculation, and therefore often you need to dynamically derive a Boolean value, and you can do that, thankfully, with the help of some Boolean operators, also known as comparison operators. Because these are operators built into JavaScript, just like plus, minus, the times operator, and so on, which don't yield a new number or a new string as a result, but which instead return or yield true or false. And there you, for example, have the equality operator. This double equal sign operator, and that's important, these are two equal signs. The single equal sign was used for assigning a value to a variable or constant. The double equal sign operator is used to compare two values and then return true or false. And you use it to check for value equality. So for example, you compare the variables a and b, and if they hold the same value, this would yield true. So you could use that comparison here in the condition or as a condition in an if statement. Of course, you also can check for values not being equal. You do this with the exclamation mark in front of the equal sign. And important here, you only have one equal sign. So the other equal sign is basically replaced by the exclamation mark here. This checks for value inequality, and therefore you could check if a and b are not equal and only execute some code if that's the case. Now there also is a special form of these two operators. You also have the equality operator with three equal signs, and therefore also the not equal operator with an exclamation mark and two equal signs. Now what's the difference to the first two operators I showed you? Well, the triple equal sign operator checks for value and type equality, or with the exclamation mark for inequality. Now what's the difference here? To find out, let's just dive here in the console in the browser developer tools on any web page of your choice, like our calculator, but that really doesn't matter. And in there, you can quickly play around with these operators. Now let's start with the double equal sign operator. Let's see what the result is if I compare 2 to 2. Now of course we get true as a result because these two values are equal. Now, needless to say that in your program, of course, you won't hard code a comparison like this. That's redundant because that will always yield true. Instead, you might be comparing two values entered by the user, for example, with the input like this, where you don't know the value in advance. I'm just using hard-coded values here to show how these operators work. So this yields true, but you also get true if you compare 2 to a string that holds a value of 2. And that's what the double equality operator does. It checks for value equality only. It doesn't care whether the two values you are comparing are of the same type. That would be the case with triple equal signs though. There, for two numbers being compared, if they have the same value, we get true. But if I compare this to a string with the value 2, I get false. So that's the important difference here. And the same, just the opposite, of course, is the case with the negation, so with the exclamation mark. Now, typically in JavaScript, you should prefer the triple equal sign or not equal operator over the double equal sign or not equal operator, simply because it forces you to write better code. You should care about the types of values you're working with. For example, if you're checking some user input and you're comparing it, whether it's equal to some number, well, you should first convert the user input to a number so that you can use the triple equal sign operator. It makes your intentions clearer, and it also avoids cases where a user might not enter a number at all. It would be better to then handle that case before you use the number instead of just getting a false result in a condition here. So typically you want to use the triple equal sign operator just because it forces you to write more explicit and clearer code. Now, of course, you can also not just check for equality or inequality. You can also compare numbers for being greater or smaller. So that's also available where you can check if number A or input A is bigger or smaller than input B. Now, both the equality and the greater than and so on operators can be used with numbers, but also with strings. Obviously, you can compare two strings for being equal, but you can actually also use the greater than operator, for example, with two strings to check if one string is greater than another string in a lexicographic way, which means C would be greater than A because it's greater than A in an English dictionary. Now, besides greater or smaller than, you also have to combine greater than or smaller than or equal operators, which allow you to compare values for being smaller or equal or greater or equal, which of course makes sense because sometimes you want to include the value in the comparison and not just check for whether the other value is greater or smaller. So these are the core Boolean operators you have. The exclamation mark operator is also important to highlight. You saw it, of course, here with the equality checks. There we can combine it with the equal signs. Now you can also use it on a value where you already know that it holds a Boolean, so on a variable where you know that it stores a Boolean, let's say, to negate it, so to check if that is not true. This might sound a bit strange right now, because you typically create Booleans with the other operators, and if you wanted to negate it, you could just, well, use the unequal operator. But you will find cases all throughout the course where you have some value which you derive as a Boolean in some part of your code, and then in some other part of your code you need that value again, so which already is a Boolean, and you just want to then run code A if that was true, or code B if it was not true, and then you can just use that exclamation mark operator to do that. Now again, we'll see all of that in action in this course and in this module here already. This is just the overview. And with that overview out of the way, let's actually see a concrete example for how we write a if statement and how we use some of these operators in there. For this, I want to reuse the calculator, and attached you'll find my version of that calculator, the one we finished in the basics module. You can of course also use yours, or just download and use mine to have exactly the same code. And in there, I want to give you an example of how we could use conditional expressions to optimize this code a bit more. Because of course this works without any if statements, clearly, because we haven't learned about them yet. But you might notice that in the add, subtract, multiply, and divide functions, we have a lot of code duplication. We always start by getting the entered number, then we set the initial result, that's always exactly the same. Then we have our calculation, which is always different. Then, however, we again just write the output or write to the log, and yes, we do pass different information in there, but actually the only information that is different is the operator that we used and the description of the operation we did. The other parameters are always the same. So there is a lot of code reusage, but without conditional statements, without if statements, there really wasn't a way around it. Well, now this changes. Now we can, for example, add a new function here, maybe just name it calculate result, something like this. And there I'll bring in my code that I have in the add function. But here I now want to write this in a more flexible way. Here I can now expect a parameter, let's say calculation type. And I expect this to be a string that describes the type of calculation we want to perform. Now we can add an if statement here by just adding if. This is a keyword understood by JavaScript. Then parentheses, where we place our condition in. And then, important, curly braces. Now this here, the parentheses here, that will take our condition. The parentheses here will in the end take our body, our code that should be executed if the condition is met. Now you don't add a semicolon after this, just as you didn't do it for the function here. And now we need to add a condition here. Now the condition could be that calculation type is equal with the triple equality operator here, equal to, let's say, add. If that is the case, then I want to set current result equal to current result plus entered number. And now I also want to provide an alternative to that, and we do that with the else keyword. Now you add that right after your closing curly brace for the if block, so for the if the condition is met block. And then you add another pair of curly braces that now marks the block of code that should be executed if this condition is not met. So if the condition is met, we make it into this first block, and therefore this code gets executed. The other code is ignored, so the code in here is ignored. If this condition is not met, then we'll ignore this code, and instead the code in here will get executed. And therefore, now let's say we want to subtract. Later I'll also cover the other cases, but for now let's say I want to subtract here. So I will just move that subtraction code in here. Now you can also, by the way, write this like this, for example. So move else onto a new line. If you only have one expression you want to execute, you could also omit the curly braces here. That would be allowed. But for readability's sake, I recommend that you always add curly braces, even if you have only one expression in there. And you also most often will find a style where the else statement or the else keyword then is on the same line as the closing curly brace. So whilst this would work, my code formatter even moves it back to this line if I auto-format the code, because this is the most common way of writing this, which you will find in most resources you find on the web, and therefore this is the style I would recommend to you. We also use indentation here to improve readability. Technically, that's all not required. Technically, just as with the functions, you could write this all in one line like this, but of course that would be super hard to read, which is why we split this across multiple lines. So now we're performing different calculations based on the calculation type we're getting. Now I also want to write my output here based on that. And for that, let me actually check for add here, all capital case. So now calculation type could be forwarded here. Now this all of a sudden is way more dynamic. It has no hard-coded values in there. Instead, this is now fully reusable because all these values are dynamic. We therefore get a different result by just tweaking these values. And now here, for the plus operator, well, we just have to introduce a new variable here, math operator, for example, which by default has no value. But then here in the add case, I set this to be equal to a plus, and now just with one equal sign, because here I'm not checking two values, I'm not comparing two values. Instead here I want to assign this as a value to the math operator variable. And in the else case, math operator simply is a minus. So that's just a string, of course. And I'm using that because now I can use math operator down here. And now these two lines are fully reusable. They have no hard-coded values in there, and therefore they work for whatever the calculation we're performing. We just have to make sure we set these values correctly. Now, calculation type should be received from outside, and therefore what we can now do is here in the add case, we can remove all that code and instead call calculate result and pass in add as a calculation type. And for subtract, we also remove all of that, and I pass in subtract, or for now actually any other value than add will do the trick. Because if we pass in add, then this function will be executed and calculation type is set equal to add, which means we make it into this block here, we make it into this block, this code gets executed, and therefore we do the same which we previously did in here in add. We add the numbers, we set math operator to a plus, and therefore down here we forward add as a value for calculation type and a plus here for math operator. If anything else than add is received, we currently always subtract the values here in the else block, and math operator is set to a minus, so here we'll pass in whatever value calculation type held, and the math operator will be a minus. So if we save that and we reload our calculator, you will notice that it works exactly as before for all these operations, and most importantly also for plus and minus, where we now reuse our code with the help of this if-else statement. Now what you're already seeing in the example I showed in the last lecture is that of course this if-else statement in the end allows us to write more reusable code. Now calculate result is a function that works both for addition and subtraction. But you also see that two cases aren't enough here. I'm not happy with just two cases. We could also be multiplying or dividing. Well, the good thing is, besides if and else, you also have else if. You can use else if to add yet another condition you want to check, and you can have more than one else if statement here. An alternative would be a nested if statement where you now have a if statement in the else statement, so that if this condition is not met, you can check another condition, but you quickly end up with deeply nested if statements in if statements in if statements if you add more and more if statements in if statements, and that can make your code harder to read. So you would typically use such an else if statement here, where you can check for another condition here. So here I could check if calculation type is equal to subtract and then execute this code. And therefore right now with this code, if calculation type is add, we run this code. If it's subtract, we run this code. If it's any other value, that's also okay, but then neither this code nor that code here runs. So in that case, none of that code executes. And this means that right now this function wouldn't really work because that down here would be kind of broken. But technically you can also have if statements in your code where you don't necessarily meet any condition. That might be okay. It really depends on which kind of code and program you're writing. Throughout this course you will also see examples of if statements where we also have the scenario that no condition is met. If you specify an else case, however, by the way, you are guaranteed that this code will always run if no condition was met in advance. So you don't need to have an else block here. Then it might very well be the case that no condition is met and no code runs. If you have an else block, on the other hand, then the else code will always run if no condition is met in this if statement. This is how if statements work. Now, however, here, I'm not just interested in adding and subtracting. Instead, I'll add another else if statement and check if the calculation type is equal to, let's say, multiply. If it is, well, then I want to take this multiplication code from down there, so set current result equal to current result times entered number, and set the math operator equal to this asterisk here. And now we can add a normal else block and just perform the division here because this is our last case. Of course, we could also use another else if block. That really depends on how you want to do that. If you just add an else block here, this means that this code runs no matter what is passed in as calculation type. So even if it's not divide but hi, I'm Max as a text, we would still execute this. This might or might not be what you want. If you want to make sure it really is divide here, then you would have to add calculation type equal to divide. So now you would just run this code if calculation type is divide. If the calculation type is neither add nor subtract or multiply or divide, none of the code would run. So that's really up to you. Here I'll go with the explicit check, but you could also just use an else statement here since we check all other options in advance. Well, and now we just have to make sure that we call calculate result. So call it here when we multiply and pass in multiply as a value, of course. And here for the division, pass in divide. And now we have way more concise and shorter code with our code reusage. We have all the logic in one function, which is good because it means we don't have to check dozens of functions to understand our code. Instead, it's all in here. And we have very lean code in here. Now let's just quickly validate this by running some calculations here. And we seem to have a problem with the multiplication. Yeah, because I have a typo here. This should be multiply. So let's fix that and reload. So now multiply this. Yeah, this now looks way better. And with that, this is the basic introduction to if statements and how you write them and how you use Boolean operators. Now, of course, here I always use the equality operator because equality is the thing I'm interested in here. This is not really a use case where I would use the greater than operator or anything like that, but we'll also see use cases for that throughout the course. And of course, you can also play around with your own basic if conditions and try them out with some numbers and some greater than comparisons if you want to. Again, this also is something, though, we'll have a detailed look throughout this module and throughout the entire course again. When comparing values in JavaScript, there is a strange behavior you might notice if you start comparing objects and arrays to each other, because these don't work like numbers or strings do. Consider this example. You have an object which has a name property which holds max as a value, and you have another object which has the same value. Now, these are not the same object. We're not talking about one variable here which I want to compare to itself. That would be redundant. But instead, let's say these are two different variables with two different objects. But of course, the objects themselves, regarding the values that are stored in there, are kind of equal to us humans. Now, still, if you compare these, no matter if with the triple or the double equal operator, you will find out that the value is not true as you might have expected, but instead that it's false. Now, why is that? Because objects and arrays, and for arrays it's indeed the same. If you had two arrays with the same values, they would not yield true if you compare them with the equal sign operators. For objects and arrays, you have to understand that they're kind of special in JavaScript. Now, I'll dive deeper into what exactly is special there later in the course, where we have a closer look at the technical details of JavaScript and some of the core things you also have to be aware of. For now, let's just keep in mind that these two types of data, objects and arrays, are special. And we can again check this by opening the console in the developer tools, here again in the calculator, but that does not matter. And in there, let's create two constants or variables, doesn't matter. Person1, which is an object with name max, so with a name property that holds a string. And then person2, which basically holds the same data. Now, if you now compare person1 to person2 with the equality operator, again, it doesn't matter if you use 2 or 3 equal signs here, you see you get false as a value here. So this generates a boolean of the value false here, not true. Even though to us humans this looks exactly the same. Now it has something to do with how that is stored behind the scenes in memory. But again, we'll dive into the details of that a bit later. For now, just keep in mind that two objects stored in different variables will never be the same. It's different if you have an object stored in a variable or constant, and then you create a new constant or variable, let's say person3, which you set equal to person1, then you will see that person3 is indeed equal to person1. But if you have another constant or variable where you assigned a brand new object, which you created like this and then assigned like this, then this will never be equal to an equal looking but differently created object in another constant or variable. So that's just something to keep in mind. Again, why this is the way it is something we'll have a detailed look later. It's also the same for arrays, as I mentioned. If you have your hobbies array here, and it includes sports and cooking, like this, and then you have more hobbies, and that has exactly the same values, written in exactly the same way, then here also you will find out that hobbies in this case is never equal to more hobbies, no matter how many equal signs you use, just as it was the case with objects. Also because arrays behind the scenes are objects, as you learned earlier. So again, why this is the case will be covered later. For now, just keep it in mind, equality comparisons won't work like this for objects and arrays. You would have to compare individual values. So for example, person1 name equal to person2 name. Since you then get access to the string that's stored in there, this again would work. So this is a comparison you can make, but the overall object or array, that can't be compared. Now, sometimes when writing an if statement, you want to combine conditions. There's not just one condition which has to be met to execute some code, but maybe two. Or you got two alternative conditions. So let's say we have three conditions in our code that should be met in an if statement. The first one is that name is equal to max. The second is that the age is 30. And the third one is that the isAdmin flag is set. So this could be a Boolean value which is set to true. For this user, it's always set to true, for example. Now, maybe you want to combine these conditions. Maybe you want to say, if condition A is met and B is met, then I want to execute the code. Alternatively, if the user is an admin, I don't care about A and B, so I always want to execute some code if his admin is true. So then you could say A and B should be met together, hence the AND, or condition C is met, and translated into code that you can write in JavaScript, and is represented with the double ampersand operator, or is represented by the double pipe operator. So in that case, the condition A and B would be evaluated together, and only if both yield true, this combined condition here yields true, and the alternative with the OR is evaluated separately. And therefore, this overall condition, where you combine these three conditions together, would only yield true if part 1 or part 2 yields true. So if isAdmin is true, the code would always run, no matter which age or name you have. If isAdmin is false, then you would only run the code if the name is Max and the age is 30, for example. So if then both A and B are true, then you wouldn't care about C. If C is true, you don't really care about A and B. That's how this concrete example here would work. Now, sometimes you also want to combine conditions differently. You don't want to have A and B combined. Instead, you maybe want to say, if condition A is true and either B or C is true, which is not how this currently would be evaluated, but if you would want to say this, then you can always use parentheses around your conditions to control that. So let's have a look at that. For that, back in our calculator, let's say here, we do check for add, subtract, multiply, and divide, right? Now the problem is, if calculate result should be called with any other value, which of course it isn't here in our code, but let's say we're sharing this code with a colleague, and this colleague tries to run this with just a value of div instead of divide, because he thinks that's all that works, then our code currently would break, right? If I call this with div here, and I have, let's say, 5, and then I want to divide this by 2, then you see the result isn't updated, and here, indeed, I get an invalid output. Now, this is the case because div is not a case handled here. Now, maybe we don't want to change the logic, how we handle that here, but we want to make sure that we don't try to create an output or write to a log if we meet none of these values. So then we could add another if statement here, which executes totally standalone, detached from the other if statements, so they don't work together magically or anything like that. But here we could check if calculation type is not equal to add, and now the double ampersand operator, calculation type also is not equal to subtract, and calculation type, and now I'm running out of space. So what we can do is we can auto format, and this automatically splits this across multiple times. You can absolutely do that. You can write all these conditions combined in one line, or you split them in multiple lines. You don't have to split after the ampersand operator. That's just a recommendation. This code would also be valid, but it's harder to read. So therefore, this is what my auto formatting tool gives me. It auto formats like this. You can generally format in whichever way you want, but this also is a syntax, a coding style, which you will find in many other resources. So it's the one I will use. So now here I also add another condition, if calculation type is not equal to multiply, and last but not least, if calculation type also is not equal to divide, then we know we have none of the values we're checking up here. So then we maybe don't want to execute this code, and therefore here what we can do in this block is we can return. Remember, if you call return, if you use the return keyword in a function, that means that this function returns a value. Doesn't really matter to us here. We don't expect a value, we don't store it, we don't do anything with it. But it also means that code after the return statement is not executed. And this is indeed a common pattern, that you check some condition, and if it's not met, you know, running this function, running the rest of this function doesn't make sense because it won't work with the values you're giving me, and therefore you might want to return. Hence, we could also grab this if statement and put it right to the top of this. This means that if calculation type is not one of the values we support down there, there is no sense in continuing with this function, so we return right away, and therefore the other code won't even execute. If, on the other hand, you have a calculation type that is add or subtract or multiply or divide, then you would continue, because this total condition here only yields true if every subcondition yields true, because we combine them with an AND. So this means only if it is not add and not subtract and not multiply and not divide, only then we return. If it is subtract, well then this here is returning false because we're checking for it not being equal. So this would return false if it is subtract, if calculation type is subtract. And therefore this whole condition would return false, and therefore this code wouldn't run, and we would continue with the next lines. So this is how that works and how we can combine conditions. In this case, with the AND operator. But of course, in other cases, you might be interested in the OR operator because you also have multiple conditions where one of them should be met. Actually, we could rewrite this with the OR operator by checking for equality. We could say if calculation type is equal to add, so now I'm not checking for inequality but for equality, or calculation type is equal to subtract, or, and now again I'll structure this across multiple lines here to make it a bit easier to read. And now here I'll check if calculation type is equal to multiply, or if calculation type is equal to divide. So now if any of these is true, this entire condition will return true. So if the calculation type is multiply, this will return true. The others will return false, but this returns true, and therefore this whole condition will return true. Because with OR, the whole condition returns true if one of the subconditions returns true. With AND, the whole condition only returns true if all subconditions return true. Here, one of them suffices. So here we make it into the if block if at least one of them is true, and therefore now we could take all that code here and remove it from there and instead move it into this if block, and therefore this code would only execute if one of these conditions is met. This means we can now remove this check, comment it out for example, because now we're checking for the opposite. Now typically you would want to use this approach here, however, because now we have a lot of code nested into the if block, which can make it a bit harder to read and understand. So therefore, checking this instead of having this if statement here makes more sense, but technically you could use both. And this also shows you how you can use AND or the OR operator. And it's of course needless to say that you can also combine them in one condition if you have AND and OR in one condition. So now with that, if I show this to you, with that added, you see that now if I try to divide by 2, we get nothing down there. It doesn't change because this entire function doesn't even execute, because we return here if we pass in a calculation type that's not one of these 4 values. And in this case, I do pass in div here, which is not one of the 4 values, hence we don't continue. If I change this back to divide here, you will of course see that now if we reload here, and now we divide, this works again. So this is how you can use the AND and OR operators to combine conditions. So by now we actually had a look at a lot of different operators which we need in different situations in our code. Arithmetic operators for calculations with numbers, or in the case of the plus operator also with strings. And also the assignment operator and these shorthands for incrementing or decrementing numbers, or for quickly assigning the result of a calculation with the plus or minus and so on operator. So these are things we had a look at. And in addition, we also had a look at these Boolean or logical operators, which we use to derive true or false. So roughly you can say where these arithmetic operators, plus, minus, the asterisk, the multiplication operator and so on, where those operators helped us with numbers, and in the case of the plus also with strings, which we could concatenate, these logical operators produce true or false, which we then in turn typically use in conditions. Now with that we have a solid list of operators. But then we also have these AND and OR operators, and these actually also are operators. Now as you already see, not all operators produce the same result. Some operators produce Boolean values, true or false. Other operators produce numbers or strings. Now, there's more where we dive into, but one thing that already is important to understand is the concept of operator precedence. And for that, attached you find a link to this webpage on MDN which talks about operator precedence. In the end, this is a fancy term for saying how are operators handled, so in which order are they executed, if you will. And the good thing is, when we talk about plus and minus and times and the division operator, the normal mathematical rules apply. So for example, if you have something like 3 plus 2 times 5, the 2 times 5 is evaluated and executed first, and then 3 is added to the result of that. So normal math. And you can override that, just as you do it in math, by using brackets, parentheses. There you can change how that is parsed. And that is all built into JavaScript, and it works just as you would expect it to be. But of course, with the AND and the OR operator, the question also is, which operator takes precedence there? And this article has a table, if you scroll down a bit, which lists the precedence of operators. And you can simply read that table from top to bottom, with the topmost operator taking the highest precedence, and therefore, unsurprisingly, that would be the parentheses. With parentheses, you can basically override the normal rules, just as we did it with the mathematical equation I showed you a second ago. Now, in this table, you'll find many operators which we haven't seen yet. Now, of course, needless to say that I'll dive into all the important operators throughout the course, but you will already recognize some of them. For example, if you scroll down further, you find typeof, you find the exponentiation operator, multiplication, division, remainder, addition, subtraction, and there you can see that multiplication and division have a higher precedence than addition and subtraction, which is just what we saw in that equation I showed you a second ago. And if we scroll down further, we see that the Boolean operators have a lower precedence. The impact of that is that if you, for example, check if 3 plus 2 is smaller than 9 minus 2, then you will actually get true, because JavaScript will first evaluate this, and then compare the results. Because the addition and subtraction operators, which I'm using here, have a higher precedence than these comparison operators. Therefore, these calculations are executed first before the comparison is made. Again, that is basically what our common sense would tell us, and it's good that JavaScript behaves the way. It would be strange if the result of this would actually be, is 2 smaller than 9, and then we have 3 plus true minus 2? That doesn't even make sense, right? So we would expect that this is evaluated, and this is evaluated, and then the results are compared, and thankfully that's exactly what's happening in JavaScript. But of course, the question, for example, is if you have 5 equal 5, and you also want to check if 3 is smaller than 6, or if 10 is bigger than 20, well, in which order is that executed? Does JavaScript check this and then check the result of this comparison? Or does it check, is this true, and this true, or this true? That, of course, matters, because if we change this a little bit and we say, is 10 greater than 5, so this is true, but here we check if 3 is greater than 6, then the result of this first comparison, if this would be executed first, would be false, because yes, this is true, but this here, this comparison is false. So with the AND operator, where both has to be true to return true, this would actually return false. Now, as you can already see here in my IDE, we will get true as a result. So this already indicates that this is evaluated first, and then this. And if either one of these two blocks returns true, the overall condition will return true. And that's in case what's happening here. Instead, if it would be the case that this is evaluated, and then this would have to be true, then it would also work like this, but not, for example, if we check if that is not equal. Then, if we say this has to be true and has to be true, we would have a problem because this first part wouldn't be true. So what I'm saying here basically is that AND has a higher precedence than OR, and indeed that is what we see here in the table. The logical AND has a higher precedence than OR, which means that first JavaScript connects these two pieces and evaluates them, and then this operator kicks in and considers the second condition as well, which means that if this is true, we override the fact that this yields false. So you can always check this table if you're not sure about some order, but actually in most cases, as I mentioned, it's just what you would expect to happen. So definitely don't learn this by heart. There also are operators in here which are quite niche, which you will never use, to be honest. So don't learn this by heart. Just take it as a reference if some behavior is unclear to you. In general, common sense is what's happening in JavaScript or what's getting applied there. And the one thing where you might not have an intuition is maybe that AND and OR thing. Well, there AND takes precedence over OR, which means first this is evaluated and then it's compared to this. And there the OR operator simply means if one of the two is true, the overall statement returns true, the overall expression returns true, and therefore this overall returns true because this is true, and therefore thanks to the OR operator, this doesn't matter, the fact that this is false, but still important to know this was grouped together because AND takes higher precedence. So instead of grouping together this was grouped together. Now in JavaScript, you also have a concept which is called falsy and truthy values. Now we learned about false and true, which were these Boolean values. Now what's falsy and truthy? Is this like kind of a strange special extra data type? No, it's actually just how JavaScript under the hood evaluates conditions. Generally, JavaScript conditions work with Booleans, true or false, but they also work with these falsy or truthy values. Here's an example. Let's say you have a constant name input which holds a value of max. Here it's hard-coded into the code, but of course that could be fetched from an input field on the web page, let's say. And then we use this in a condition here where I compare the value in name input to the hard-coded value of max. Well, we know that name input stores max, and therefore this of course would work. To be precise, this condition yields true in this example here, so it yields a Boolean value, and therefore this of course works. That's what we saw thus far. Now consider this code snippet here. We again have name input which holds max, in this case hard-coded, but could be fetched from the input field on a web page. But now in the if condition, I don't compare name input to any concrete value, I just have if name input here. And this name input constant here, of course, holds a string, not a Boolean, right? We initialize it one line above it, so this holds a string, not a Boolean. And still this works. And this works because JavaScript tries to coerce values to a Boolean value if a Boolean is required, as it is the case in an if statement. So yes, if statements work with Booleans, but JavaScript tries to convert a value to a Boolean if it doesn't get a Boolean comparison and also not a Boolean itself. So for example, if you have a variable which you pass into an if condition, which you don't compare to anything, but you just say if that variable, and that variable holds a value of 0, then this will actually be treated as false. So 0 is treated as false in a condition. Any other number, including negative numbers on the other hand, are treated as true. So 0 is kind of a special case which JavaScript treats as false. Now when might this come in handy? Let's say you're doing some division and you don't want to divide by 0. Now let's say the value is provided by the user enters a value in the input, and you want to make sure that you don't divide by 0. Of course you could check if user input is equal to 0, and if it is, you return, or you just use the shortcut of just plugging in the variable name. And actually again, our calculator is a great example. It actually never makes sense in our calculator if the user enters 0 here. Adding 0, subtracting 0, or multiplying or dividing by 0 doesn't really make sense. You could say multiplying resets it, but let's say we don't want to have that case. And dividing would even be illegal. It's not allowed to divide by 0. So what we could do in the calculator here, in the calculate result function, besides checking our cases here, we could also make sure that we return if, and now we can actually use the OR operator here, if the entered number, and for that we just have to extract it before we run that code here. So if the entered number here is equal to 0. Of course we could do that. What this would now do is, it means we would return right away if either the calculation type is not add, not subtract, not multiply, and not divide, or if the entered number is 0. So let's test this. If we reload this page, of course, everything works here. But if I enter a 0 here, you see our output doesn't change down there. So that works. Now, again, we can do that, but we can also say if entered number, or to be precise, since this would be treated as true if it's anything but 0, we can add an exclamation mark in front of this. Now this might look strange at first, but what this says is if not entered number. You might remember that slide at the very bottom here, the exclamation mark operator, that's what we're using here. This negates a value and checks if it's not true. So in this case, entered number, if it's 0, is treated as false by JavaScript. It's falsy, and therefore by adding an exclamation mark in front of it, we kind of invert that value. We say if that's not the case, then we want to make it in here. Now, since 0, if the user entered 0, is treated as false, this means if not false, which is true, then execute this code. So if entered number is a falsy value, then not falsy will return true. And if we return true here, well, then we make it into this if block, and therefore we return from this function. We don't execute the function. If entered number is any other number but 0, including negative numbers, then it's truthy, and then with the exclamation mark in front of it, it's converted to false. So if false, we'll never execute the code in there, right? Because this code only executes if this first condition is true, and therefore we don't make it in here, and we don't skip function execution by returning early. This is how this works, and this is the idea behind the truthy and falsy values. You don't always have to make an explicit comparison with the equal or greater than operators. You can also just throw in the variable or the value which you're interested in, and then just take this as a condition itself. And if it doesn't hold true or false, JavaScript tries to convert it to true or false. And there, 0 is treated as false, any other number is treated as true. Now for strings, an empty string is treated as false, any other string is treated as true. And for objects and arrays, it's important to understand that all objects and arrays, even empty ones, are always treated as true. So an empty object is not treated as false, it's always treated as true, no matter if there's data in it or not. Null, undefined, and not a number, by the way, are always treated as false. So these are the truthy and falsy values you can keep in mind. You can take that slide, it's attached, and kind of print it out and put it next to your desk. These are the special cases in JavaScript. If you just throw in a single value or just a variable with a value in it into an if condition without a comparison operator, so without the equal sign or the greater than operator, so just the variable like this, then JavaScript will look into the variable or look into the value, and if it's not true or false already, it will try to convert it to true or false, and this is how it then does it. Now that's it for our calculator and for the basics about if statements. Before we advance to loops, I'd say it's definitely time to work more with if statements to get a better feeling for them, for the comparison operators, for booleans, and for all these things which we used a bit here, but which is still brand new and therefore definitely needs more practice so that you feel confident using if statements in your code. Now, to practice all that if statement stuff and the related concepts a bit better, let's work on a new little application, a new little project, a little website here. As before, fully driven by browser-side JavaScript so that we can experiment with the things we learned and get a nice visual output for that. Now, this is the website I loaded. You find it attached, of course. Again, it's made up of an index.html file and of an assets folder. The assets folder holds a scripts folder with an empty app.js file and a vendor.js file, which is kind of a black box to us right now. It basically establishes a communication channel, you could say, between our HTML code and JavaScript so that we can manipulate the document we see there, something we will, of course, learn in great detail later in the course. We're just not entirely there yet. For now, we just treat this as a black box that yields us some global variables we can use to listen to button clicks and so on. The app.js file is where we will write our code, and of course we also got some styles here in the app.css file. Side note, all these styles are optimized for Chrome because I recommend following along with Chrome here, not because JavaScript wouldn't work in other browsers, but simply, especially for the styles now, so that we all always have the same thing on the screen. Now, this is what we do have on the screen, and what we're building is a little monster killer application. We got the health of a monster, and we got the health of a player. We also got a bonus life. In case our health drops to 0, we'll be able to recover one time only. We got 4 buttons which we can press to attack the monster, to launch a strong attack against the monster, to heal ourselves, and also to output some log information about the past rounds. Now, that's what we'll work on. Right now, nothing works because all the logic is, of course, something we will need to write. And maybe you can already see some of the if checks we probably will perform. Maybe some related to the buttons, whether we launch a normal or a strong attack. But also definitely we'll need to check after each round whether we won or not. So whether the health of the monster and or the player is below 0 and we therefore need to quit the game or stop the game. So that will be some if checks. And actually there will be a couple of other if checks as well, because we'll also add a functionality where when we load this page, we actually asked the player how much health monster and player should have. 100 health points, 50, 1000. And we'll need to check whether the value the user entered is a valid value, and so on. So there will be a couple of places where we need if checks, and therefore a couple of places where we can practice the things we learned. So let's dive right in. Now, how do we dive right in? I would suggest let's start by making sure that this attack button does something, that we actually shrink these health bars. Now, as I mentioned, we need to configure how much health is available, and later we'll ask the user of this web page for a starting value. For now, we will hard code it. So here in app.js, I will start by adding a constant, which I'll name chosen max life. Again, later the user will be able to choose that, hence that variable name. Right now, I will hard code it, and I will set it to 100 health points. Now, in addition, I'll also set an attack value here. Now, this also is a constant because this will not change throughout the program lifecycle. By the way, the health, of course, will change. So this actually should be a variable with let. My mistake. So this should be a variable. The constant here, however, will not change. And the order, by the way, does not matter. You could have the variable first, whatever you want. But I like to have my constants that never change first. And the constant here which won't change is the attack value, which I'll set to 10. And of course here you can experiment with different values. This is basically how hard we hit the monster, though I will say in the vendor.js file, we got a little randomization logic built in so that the attack value I set up here will actually be treated as a maximum value, and we will generate a random value between 0 and that value to have a little bit of randomness in the game. Now, also one little thing which I want to change here. Attack value is a constant which will never change throughout the entire program. Therefore, it's a constant, as I just said. We can also leave it like this, but for such a global game value, which we really hard code in there, so which we don't derive from, let's say, some user input, which thereafter never changes, but which we as a developer set up as a global value, which you just hard code into your code, it's also quite common to use all uppercase characters there and separate words with an underscore to make it really clear that this is a global value which you just hard coded into the code as we did it here. It's not required. Technically, it doesn't make any difference. It's just a convention you see in some programs, and therefore one which I want to establish here. Again, not a must use, but an option. So that's the attack value, the maximum attack value we can get as a player. That's the max life for both the player and the monster. And the first thing we can do, therefore, is we can call a function which is exposed by vendor.js, the adjust health bars function, which takes the maximum life and which then just sets the maximum life in our user interface, so in the HTML code in the end for these progress bars. So here we can call adjust health bars and simply forward the chosen max life so that this gets updated on the screen whenever we load this game. Of course, we see no difference here. The bars were full before that, but if you inspect them actually with right-click inspect here in Chrome, you see the HTML code as it's configured for this running web page, and there you see the max value is set to 100. The current value is also set to 100, and if you would change the chosen max life here to 50 and reload, you would see that these values also change to 50. So that's the impact we're having here, just so that you see how this all is connected. Okay, so with that, we got the chosen max life set up. We're setting this in our web page, so to say. Now we want to connect this attack button here to a function which we execute, which then lowers this health. So for that, In the vendor.js file, we expose this attack button. That's a constant which we can use. By the way, these constants are not written in all caps because these don't hold hard-coded string or number values, but instead references to parts of our HTML code, so parts of our web page. And there, this is not such a global hard-coded value, but it's a bit more dynamic, even though it of course also won't change whilst the app is running. So we can refer to the attack button constant here, which is basically a reference to this button. And we can use this here to then also add an event listener here. And this event listener should listen to the click event and then fire a function, which I'll add here, which I'll name attack handler. And now the name of the function is totally up to you. Previously in the course, I used a different naming scheme. Now, from now on, I will use a different one where the functions which I assign to event handlers will always be named some description of what the function is there for, and then handler at the end. This is absolutely not a must do. It's also not the only convention you will find out there. Some people also use a convention where these event handler functions start with on, and then, for example, on click or on attack. Or you just name it attack monster if you want to go with that, just to make clear which functions are attached to an event listener and which functions aren't. I will go with that attack handler or with that handler convention here, but again, that is optional. So attack handler is the function I'll point at here on my event listener, and in this function I now want to launch an attack towards that monster. Now to launch that attack, we can have a look at the vendor.js file, and there we actually have that deal monster damage function. What this does is it calculates a random amount of damage based on the damage we feed in as a parameter. Then it adjusts the monster health bar, so the health bar we see on the page here, and it returns the damage it calculated, so that we can also use it in the app.js file. So I want to call deal monster damage here, and I want to pass in my attack value here. And this will return the damage that was dealt, which I'll store in a damage constant, a constant because this value will not change for this function execution. So I will store it in this local constant, which is available inside of this function thereafter. And now we can use that stored damage to adjust our monster health. Now for that up here, I'll add a new variable, monster health or current monster health, which I'll set equal to chosen max life, which of course renders this variable a bit redundant. It will become more important later once we let the user set this. For now, it's just like a dummy data container. We could of course also initialize current monster health to 100 here. But again, since later this variable will be populated by the user, I'll use that extra variable. And the current player health can also be initialized to the chosen max life. Now that current monster health should be reduced by the damage which was dealt down there. And for this, of course, we can use the minus equal operator and set this to damage. This means that current monster health is set equal to current monster health minus damage. Now, the UI is updated by the deal monster damage function, as I explained. And with that, we should be able to attack the monster with a normal attack. If I save this, and I reload, and I click attack, you see the monster health bar shrinks by different amounts because it's random, but it shrinks. Of course, we have no win condition though. So it would make sense to add this, and therefore, of course, we'll need an if statement. So it's time for our first if statement. We want to find out if after an attack, we won. So here in the attack handler, we could add an if statement with the if keyword and check if the current monster health, after we deducted the damage from it, of course, if that is smaller or equal to 0. Because I also want to check for equality because the monster is dead not only if its health is below 0, but also if it's equal to 0. If that is the case, then we know that we won. So in this case, we could throw an alert where we say, you won. So this code here will only execute if this condition here is met, and this condition is only met if the current monster health is below 0 or equal to 0. So with that, if we now reload this and we launch a couple of attacks against the monster, spam this button until the health bar is below 0, we get this 1. Now please note this message is output before the health bar updates, simply due to the way JavaScript works here. It blocks the UI update until we dismiss this dialog here, but the general logic works, and if we dismiss it, we also see the health go down. So this works, and this is our first basic if check in action. Now of course, it's a bit boring if we can attack the monster, but the monster is not able to fight back. So what we actually want here is to adjust the logic to let the monster fight back. To do that, after we hit the monster should immediately lash back at us. So it should automatically hit us after we hit it. Now for that, in vendor.js, we got the deal player damage function. It works basically like the deal monster damage function. It takes some damage, then calculates a random damage which is actually dealt, adjusts the player health bar in the UI, and returns the dealt damage. So in app.js, I can take advantage of this. For that, we just need to define what's the maximum damage of the monster. And here I'll add a constant monster attack value, again hard-coded into here, and I will let the monster hit me back with, let's say, a maximum damage of 14. So more than we can hit it for, which means that right now we will need a lot of luck in order to win, because these are maximum damages and the monster has an edge there. Of course, the game will evolve throughout this module and will also make the other buttons work, which will give us an edge again. So let's take that monster attack value here to let the monster deal some damage to us. And for this, I will get my monster damage, let's say, or player damage, depending on how you see it. It's the damage dealt to the players, so maybe player damage makes more sense. And for that, I will call deal player damage here, forward the monster attack value, and then reduce the current player health by that amount, again by simply deducting player damage with the minus equal operator. Now here, we want to check if the player won, so if the current monster health is smaller or equal than 0, or if the monster won. Now you might think that we simply add an else block, right? Because if we haven't won, if the monster health is not below 0, then we lost. But that would actually be wrong. Keep in mind that the attack handler is executed for every click on the button. So we run this check here for every button click. And on most clicks, especially when the game just started, neither party won. So we don't want to let the player lose in the else case, because if we do that, if we say you lost here, you will see that if we reload here, right after the first attack, we get the you lost message. Which makes sense because we run this check on every button click. Now, after the first attack, we certainly didn't win, so this condition is not met. Hence, we make it into the else block and we lost. So else is not right for this scenario. Instead, I want to check else if. So if we haven't won, if maybe the monster won. So here I'll check if the current player health is smaller or equal than 0. Now, of course, you could argue about this logic, because what I do at the moment is I let the player hit the monster, and then the monster immediately hits back, and only thereafter I check if the player won, which means the monster already dealt damage to us, and still, even if that damage took us below 0, we will have won if we also took the monster below 0, if we also reduced the monster's health below 0. Which means the monster's damage basically is irrelevant if we also took the monster's health below 0. And of course you could argue about that. Maybe you instead want to check if the player won here after the player dealt damage, and therefore don't give the monster a chance of dealing damage to us if we won. Or you just don't care, you always execute both, and then you give the player the advantage of checking the monster health first, and therefore the player wins, even if the player's health also is below 0, because the monster's health is below 0 after this attack. So a lot of talking about how you look at this. From a technical perspective, it's way easier. We check if this condition is met, so if the monster health is below 0. If that is the case, we won. If that's not the case, we check if maybe the monster won, so if the current player's health is below 0. And if neither of the two is the case, then nothing happens in this if statement. Neither of these two code lines is executed, so neither the you won alert nor the you lost alert is shown, and instead we just finish the function execution and we're done. And that will be the case for most clicks, for most executions, especially at the start of the game. So with that, if we now save this and we reload, let's attack, and you see the monster is hitting us real hard here. We had a couple of weak hits and therefore we're probably going to lose. So let's see what the end result is. And yeah, we get the you lost message here once our health dropped below 0. So the else if check is also working here. Now to fine tune this a bit more, we could of course say, yeah, we really want to tweak this and we shouldn't be able to win if our health is also below 0. Instead, it should be a draw if both health values are below 0. So here we could say, we won if the monster health is smaller or equal than 0, and, now with the AND operator, the current player health actually is above 0, so greater than 0. Not greater or equal, because if it's equal we lost, but greater. So we can only win if the player's health, still is above 0. And the same for the monster. The monster only wins if the player's health, is below 0, and the monster health, on the other hand, is above 0. And that, of course, means that if both health values are below 0, it's a draw. So we could add else alert, you have a draw. But of course, that again would be wrong, because if we do that, keep in mind, attack handler executes for every click. So this else case will basically execute whenever neither of the two conditions is met, and that most of the time will be the case. So now again, we have the same case as before. On the first click, we get that you have a draw message. Because else, again, for this scenario, not always, but for this scenario is wrong. Instead, here I want to check else if the current player health is smaller than 0, smaller or equal than 0. And the current monster health also is smaller or equal than 0. Only in that case we have a draw. Now to simulate that, let's start with a max life of 5, where we have a realistic chance, or a more realistic chance, of actually launching an attack that takes us both below 0. And let's have a look at this. If I now click attack, yeah, right away I have a draw. You might have to test this a bit more often, because since the damage is calculated randomly, you can certainly have situations where you hit the monster for 2 and the monster hits you for 6 and therefore you lose. But after clicking this a couple of times, you should get that you have a draw message here. So with that, let me take it back to 100. With that, we now have logic that works correctly. Let's also check for a regular win or loss. Yeah, we lost here. And with that, we got our basic if statement with if, else if, and different logical operators, as well as the AND operator to also combine multiple conditions. So already quite a lot of the things you learned about in the past lectures are getting applied in this first crucial element of our game. So now that we got our basic attack handler, let's also make sure we can do a strong attack. We can perform a strong attack here by clicking the strong attack button. Now for that, in the vendor.js file, we find that strong attack button constant, which in the end gives us access to that strong attack button in our HTML code. And therefore, of course, in app.js, we can add an event listener where we again listen to a click event on that button. But now I want to execute a different handler, a different function, of course, a function which deals more damage to the monster. So for that, I'll add a brand new function here. The strong attack handler sounds like a sensible name. And let's connect that to the event listener, just as we connected the attack handler. And in there, I generally, of course, want to do the same as I do here. So I will copy it over, though, as you already know by that point already, when you copy code, you most of the time can avoid it and write more elegant code instead. So I will copy it for now, but this will not be the final code. Instead, especially with if statements, we can write this in a more reusable way. Nonetheless, let's start like this, strong attack handler. Let's go up there and define a strong attack value so that we have some value which we can change in one central place. up here in this constant, which is our maximum strong damage that is dealt. And maybe let's go for 17 here. Again, you can play around with these values. So the strong attack value is now, of course, what I use in the strong attack handler here when we deal damage to the monster. The damage the monster deals to us stays the same, so the monster only has 1 damage it can deal to us, 1 maximum damage. And the win condition check here, of course, also stays the same. So now with that should already be all. If we now reload, we can press strong attack, and as you see, the monster health declines, but player health a bit more. It's really close. Yeah, we might be winning. We won. So a close finish, we won, and that works. And right now, of course, we don't reset the game thereafter, so we can continue clicking these buttons, which is kind of redundant. We'll take care about this later. And we're also not taking care about our bonus life in case we're losing. That's also something we'll take care about later. For now, let's focus on the strong attack handler, which does its job, but as I mentioned, lots of code duplication here, which is never a good sign. So how could we minimize that? How could we reuse some code? For that, let's simply analyze which code is equal. And, well, that's a quick analysis. All the code is equal. The only thing that really differs is the maximum damage value we're passing to deal monster damage. So that's really a redundant extra function we have here. Well, to reduce the code duplication, let's add a brand new function, which we maybe just name attack monster, because that's what we'll do. I don't add handler at the end, because this will not be attached directly to an event handler. Instead, attack monster should be a function which I want to call directly from inside attack handler and from inside strong attack handler. And I want to pass a parameter to this attack monster function that identifies the attack mode, if you want to call it like this. So of course you can give this parameter any name you want. I just go with mode here, but the name is totally up to you. And in here we can then check the mode in the if condition. And let's say the mode is a string. You could alternatively also go with numbers and say 0 is the normal attack, 1 is the strong attack. Here, since it's easier to read, I'll go with the string value and check if mode is equal to attack. If that's the case, then I want to do my normal attack and calculate the value based on that. Otherwise, I will go with the strong attack. So in the end, what I want to do here is I want to create a variable which I'll name max damage, which initially is empty. And if the mode is attack, I'll set max damage equal to attack value. Otherwise, I'll set max damage equal to strong attack value. And of course, here I can use else because I will call attack monster from these two functions. And I either pass in mode, which is a string of attack, or I pass in no mode or some other string, and then this will automatically treat this as a strong attack. You could, of course, just as before with the calculator and the division, also be more specific and check if mode is equal to strong attack and simply do nothing if the mode is neither of the two values. So either of the two code snippets or approaches will work, just what they do if you pass an invalid mode is different. You can either always perform a strong attack or, as with this case here, only perform a strong attack if the mode is really set to strong attack. Now, why am I doing this? Why do I create that max damage variable, which is then set to different values here? Because now we can actually grab this entire code here from attack handler and move it below this if statement, and now simply pass max damage here to deal monster damage, because now the max damage is dynamic and it's dynamically set here based on the mode we receive as a parameter here in attack monster. And all the other code is always the same, which makes sense, I guess. So now we just have to call attack monster from inside the attack handler. And since this is the function that's executed when we click the normal attack button, here as a value for mode, I want to, in the end, set my max damage to the attack value. I'll therefore pass a mode of attack in there. So I simply forward attack here. And now we can call the same function from inside the strong attack handler. and forward strong attack. Pass in strong attack as a value for mode. Now, in case you're wondering why we're not directly setting attack monster here on the event listeners, we could almost do that, but keep in mind that here we can't specify the value for the parameters we're passing in. So this mode parameter, which we expect here, when we attach a function to event listener, we can't specify this. Actually, we can, but we haven't learned it yet. So for now, let's take this extra step of doing it in our handler functions. Now the handler functions are very lean. They execute the same function with different data which is passed in, and in that function we then take that different data, use it in an if statement, and therefore change the one piece of logic that does differ for both buttons. So now if we save that and we reload, I can launch normal attacks or strong attacks against the monster, and both works as before. Now here we have a draw actually. Good to see that. And we do this in an elegant way by reusing code with the help of an if statement. So we can attack the monster. What about healing? The heal button doesn't do anything. And therefore it would make sense that we also react to clicks on that. It's the heal button constant here. So we want to add an event listener to that. And of course we want to trigger a function when this button is clicked. So for that, we can register a new function, add it here maybe, the heal player handler or whatever you want to name it. And this heal player handler function should be triggered when the heal button is pressed. Now what happens in that heal player handler? In the end here, I want to heal the player by a certain amount, and that amount should also be set up there so that we can conveniently change it in one single place for the entire game. I will name it heal value and maybe set that to, let's say, 20, which is a lot, and you can definitely play around with different values here if you want to. Now in vendor.js, we will also have the increase player health function, which is in the end the heal part. This does not randomly calculate a value, so instead the heal value we have will always be the real heal value applied. So there is no randomness involved here. This will just update the player health bar in the UI. So now with the heal value set up there, we can use it in the heal player handler. And there, I, in the end, want to call increase player health, which is that function I just showed in vendor.js, and forward the heal value so that we can heal the player. And thereafter, of course, still the monster should be able to hit us. So in the end, we will heal, but we will also take an immediate hit by the monster. So the monster hits us after every turn, no matter if we attacked it or if we healed ourselves. So we want to let the monster attack us. So that means that this code here also needs to run. And of course, since the monster will hit us, we could, even though we healed ourselves, we could theoretically be dead. Not really, with a heal value of 20 and a max monster attack of 14. So in this scenario, we actually can't be dead. But if the monster would hit us for a value of bigger than 20, so a maximum damage of bigger than 20, or if we would heal for less, then we could be dead. And since these values can be adjusted by you as a developer, I want to handle that case as well. So we could be dead, hence I also want to have my win condition be executed here. Certainly the player can't have won because the player dealt no damage to the monster, but the monster might have won if values were different. So in the end, running this entire code again doesn't sound too bad. Now obviously we can copy it over, but you know what you learned about copying code, not the best idea. So instead, let's add a brand new function, which we maybe name andRound. And in there, I have my code where the monster hits us and where we check whether we won or the monster won, or if we have a draw, or if nothing happened. Now this andRound function can now be executed whenever we had this code before. So in the attack monster function, after we dealt damage to the monster, we can call andRound like this. And now this will, andRound, let the monster attack us and check the win condition. And we do the same here after healing. Call andRound. Again, code reused efficiently, very lean functions defined up there, and a reusable end round function, which we can call whenever a round is over. So even if we would add more options here. With that, if we now hit the monster and we heal ourselves, you see the health goes up a bit. Here we go. And so on. But we can never heal to full because we always get damaged by the monster, or at least it's very hard. One problem we have with this heal logic right now, though, is that we can actually also heal if we already have full health. So if I click heal here, we actually take damage because the monster still hits us, but with enough luck, we can actually go above our maximum health. By the way, you will also see that if you press heal a lot, you eventually lose, which is very strange. Now that's also something we'll have to fix. Now the reason for us losing is that whilst our progress bar is updated by calling this function, our health, which we manage here, the current player health, which is important for our win condition, actually isn't adjusted. We adjust it when the monster hits us, then we reduce our health. Here, current player health reduced. We also reduce the monster health when we hit it, but we don't update, we don't increase the current player health if we heal ourselves. So that's one thing we have to do. We have to set the current player health plus equal to heal value here. Otherwise, the progress bar health does not reflect our internal game health. And in addition, I want to make sure that we can't heal for more than our maximum health, so that we can't go above our maximum health. To guarantee that, we can actually add a new variable here in the heal player handler, maybe named heal value, like this, which of course is different from our constant here. It's written in a totally different way, and JavaScript is case sensitive. And of course there also we have an underscore, which we don't have here, so it's a totally different variable. Even if it would be the same, thanks to variable shadowing, we could have the same name here in a function as we have globally, by the way, but this is a brand new variable, doesn't even have a shared name anywhere. And I'm adding this variable because now again, we can add a if check here and check if the current player health is greater or equal than the chosen max life, which is hard-coded to 100 here, which later can be set by the user. So the chosen max life minus the heal value. Now what does this comparison do? Now keep in mind that thanks to operator precedence, this is evaluated first. So this basically at the beginning of the game, for example, calculates 100 minus 20, so 80 as a result. And therefore we check if the current player health is greater than 80 here, which at the beginning is the case, because at the beginning the current player health is equal to the chosen max life, which is 100. 100 is greater than 80. If that's the case, then we know that the heal value is either just enough to fully heal us back up to our max health, or to even heal us beyond that. Put in other words, if we just applied heal value to improve our health, we would at least go up to our initial health, maybe even go higher than that. So in that case, what I want to do, I want to maybe throw an alert where I say you can't, and now I want to use a single quote here, even though my entire string is surrounded by single quotes. To fix that, we can use double quotes to surround the string. Then I can say you can't heal to more than your max initial health or something like that. And thereafter I set the heal value equal to the chosen max life minus the current player health, which basically means we heal the player back up to his initial health, but not above that. Now, else, which is the case if our current health is not greater than this difference. So for example, if our current health is 60, this difference here for the current initial values always is 80. Then if we have a current health of 60, we don't make it into this block, then we go into the else block, because now we know if we apply the full heal value of 20, we will certainly still be below our maximum. So we don't need to tell the user that we healed him for less. Instead, we can apply the full heal value, so the full 20 health points in this case here, to heal the player. So then I will set heal value equal to our global heal value constant here. So here we apply the full 20 health points in this case. Here we might also apply the full 20 health points if the current player health is exactly 80. But for example, if it's 90, this here will only be a value of 10 because we can't heal the player for more than up to his maximum initial life. So why did I do all of that? Because now heal value is a dynamic value which takes the maximum amount of life and the current amount of life of the player into account. And therefore now we increase the player health by this heal value and also our in-game player health by this value. And now if I save that and I reload and I click heal right at the start, we get this alert and we are healed back up, but since the monster immediately hits us, we actually don't see that. So healing at the beginning of the game just is stupid, as you can see. But if we then attack, for example, here I get a warning. Still a warning, but here we see the effect a bit because the monster didn't hit us as hard, and so on. So this now works, and if I'm a bit lower on health, we don't get the warning, of course. We only get this if we're high on health, and we would potentially heal ourselves up for more than our max health before the monster then hits us again. So this is the healing functionality. Now we also don't lose because of some out of sync in-game health and health bar health. And therefore now we successfully added a heal functionality with another if check example, in this case used to ensure that we can't heal for more than up to our maximum initial health. So we can attack the monster normally, we can launch a strong attack, we can heal, we got various checks in there also to see whether we won. One thing we're not doing is we're not resetting the game after we won. We're also not asking the user for an initial max health value. Right now we're hard coding this to be 100. I said that I want to let the user of the game, of this app, of this website choose that value. And what we're also not doing is we're not utilizing this bonus life. Now let's maybe start with the bonus life. The idea behind the bonus life is that if we're low on health, and we would die, like now, if I click attack and the monster hits us, we would very likely die. Then we actually don't die, but instead we consume this bonus life and we got, well, time or an opportunity to come back. Okay, so I didn't die, now I should die, I lost. And here we shouldn't lose, but instead consume the bonus life, freeze our health. So don't reduce our health for this turn, and thereafter we have a chance to heal back up, or if it was close, maybe now launch an attack towards the monster that kills it. And therefore we have one chance to recover throughout the entire game, even if we then restart it later. So this is the idea behind the bonus life. Where should this bonus life come in there for? Well, the end round function makes sense because this is where we check whether we lost, and here actually, before we check this, we should check whether we have a bonus life. So in here, we can add another if statement and check if the current player health is smaller or equal than 0, which means we would be dead. And now I also want to check if we still have our bonus life. Now for that, since it's exactly 1 which we can consume, I'll add a new variable up there, which I'll name has bonus life. And I give it this strange name because this will actually hold true initially. So this is now a variable that just holds a Boolean value, true or false. Not a truthy or falsy value, but a real Boolean. And Boolean variables are typically named like this, where you kind of indicate what you're trying to control here. So here has bonus life. In other programs, you might have something like is logged in to indicate whether the user is logged in or not, which also makes sense to be true or false. Of course, we don't have that here, but that would be another example. So here bonus life has bonus life is true, and therefore here I can check if we would be dead and we have a bonus life. So if this is true. Now we can't just check this like that. You could say equals true with triple or double equal signs, and that would not be wrong, that would work. But as I also showed you on the falsy truthy slide, if you just reference a variable without a comparison operator, JavaScript will actually try to convert this to true or false and then take this in its condition. And here, of course, this conversion is really easy because there is nothing to convert. This is a real Boolean. It is true, so JavaScript will check if this is true and this is true, which means we would be dead, but we do have a bonus life. And in that case, I'll set the has bonus life variable to false, because now we lost our bonus life. And I will call remove bonus life, which is a function provided in vendor.js, which will in the end just update the UI. And now I also want to make sure that our health is now not below 0. So actually here at the beginning of the end round function, I'll log in the user's health before the monster hits him. So initial player life is here set equal to current player health. Maybe also name this health therefore. So initial player health is equal to current player health. Thereafter the monster hits us and the current player health is reduced. But since we stored a copy here in initial player health is not affected by changes in current player health. And therefore here we can set back the current player health to the initial player health. So we reset it to the health before the monster hit us. That's what our bonus life does here. Now let's just also inform the player about his luck and say, you would be dead, but the bonus life saved you. And of course, also make sure we update the UI appropriately by using a function you find in vendor.js, and that's the setPlayerHealth function, which just updates the player health bar. You simply pass it the health to which it should be set. So here, that's of course the initial player health, to which we also reset our in-game health. And with that, now let's save it, reload this game, and now attack the monster a couple of times so that we would die. And now we would normally be dead, but the bonus life saved us. And indeed here, we got a little bit of health left. So maybe let's try heal up. And now we won. You also see the bonus life was removed here. So that's the bonus life, again, with some if checks implemented. Here also with a variable which we don't compare to anything, which again, we could do, but it's simply redundant, because if you don't add a comparison operator, JavaScript will try to coerce this value to true or false, which here is simple because it is a real Boolean, and therefore we can use it like this in the condition, and hence this works. Now that's the bonus life functionality. What about resetting the game once it's over? For that, I will add a new function here, which I'll name reset. Not reset game, because that's actually a function I have here in the vendor.js file to update my health bars there. So I will just name it reset here in the app.js file, because these names are shared globally across scripts, as you learned. And here in the end, I want to basically do the same I did here. So I want to copy that code into reset without let though, because I don't want to reinitialize these variables. Instead, I want to use the global ones and just set them back to the chosen max life here. I will not reset the bonus life. That's not the idea of this game here. I don't have a function in vendor.js to update the UI. So if you would want to add such a functionality, you would have to write such a function on your own. Not the goal here. Bonus life only exists once across all games. I will just reset the health, and therefore also call reset game here, which is that function in the vendor.js file which resets the health bars there. Now we can call reset whenever we want to reset, and that of course should be the case whenever we lost, we won, or we had a draw. So whenever the game is over. This means here in end round, in all these cases here, we can call reset, just like this. Now there's nothing wrong with doing it like this, calling reset in 3 places. A bit of code duplication, which you can't really avoid. If you would want to rewrite it, and I would argue that this is not necessarily shorter, but if you would want to rewrite it, you could add a new if check which runs after this one, where you check basically all conditions combined, and then you call reset. So here you would check if current monster health is smaller or equal than 0, and the current player health is greater than 0, in which case the player won. Or, and now we got and or combined. Due to the way operator precedence works, this is executed first, thereafter the part after or, and then both combined with or. So after this, I check this condition here. Let's now split it across multiple lines to make it easier to read. Here, my IDE automatically added parentheses for readability. These are not required. Due to operator precedence, this code will work in exactly the same way, no matter if this is wrapped into parentheses or not, because AND has a higher precedence than OR, which means this is evaluated first, then this, and then the result of both operations are compared with this OR operator. So if this yields true and this yields false, for example, the overall result will be true, because with OR, if one of the two conditions is true, the overall condition is true. Now, of course, we're not done here, though. I checked for the monster health, for the player health. Now we can also add another condition, and that would be this one here. And with that, we have all these conditions up there combined, and we call reset thereafter. Now, actually, we can shorten this, though, and then this becomes a better alternative. I wanted to show this first to practice the combination of AND and OR. In the end, the only thing we care about here is whether the monster or the player health is below 0, right? Because in either way, one of the two lost, or it's a draw. But we don't care whether it's a draw or if we have a winner here. We just care whether some value, some health is below 0, because that means the game is certainly over, no matter who won or if it's a draw, and therefore we want to reset. So we can shorten this a lot, and again, then it becomes a real alternative to calling reset 3 times here. We can shorten this a lot because all we have to do is we have to check if the current monster health is smaller or equal than 0, or if the current player health is smaller or equal than 0. Now we have a very short condition here, and we want to call reset if that's the case, if that yields true, because that means we have a winner or we have a draw. In either case, we want to reset. So now with that, let's save it, let's reload, and let's try. Let's hit this, and we won after clicking OK. This should normally reset, but it didn't. Yeah, because reset game, of course, takes a value here, the value to which it should reset our bars. And that's, of course, the chosen max life, which we need to pass in here in our reset function. And with that, let's give it another try. Let's hit attack here. Looks like the monster is going to win now. Well, we have our bonus life, right? But if I click attack again and again, now we really lost. But thereafter, we reset this. And now maybe with a couple of strong attacks, we should win. And we do. And now let's see if I can get a draw here. But that's actually quite hard, to be honest. Yeah, it's really hard. You might get a draw here. You will see that even there, you will reset this in the end. Yeah, here is a draw. Yeah, so this all works. Now we can reset this. Really nice. And with that, the one thing that's missing here is that we let the player, the user of this website now, not you as a developer, but the user of this website, that the user may decide what the initial health values are. 100, 50, 1000. That is something the player should decide, and that's what we'll implement next. Now, how can we let the player of our game choose that initial max life here? For that, JavaScript has a nice little built-in function. So the browser has a nice little built-in function, I should say. And in JavaScript in the browser, you can therefore use that. And that's the prompt function. It's a bit like alert, which shows a message dialog. This also shows a dialog, but it shows a dialog where the user may enter something. So here, first of all, we have some text which is displayed to the user. For example, maximum life for you and the monster, to tell the user what he should enter. And then you also can define an initial value, which should be a string. So for example, 100. Now, if you save that and you reload this page, you're presented with this prompt where you can enter a value, for example, 70. Now, if you hit OK, nothing happens right now because we're not doing anything with that entered value. The prompt function actually returns the value the user entered. So here I got my entered value constant, which holds that value the user chose here. Now that will be a string, not a number. That's important, but I want to have a number here to do my calculations correctly and not start concatenating strings or anything like that. So I want a number here, and therefore we should convert this to a number. Of course, you learned how that works. We can simply use parseInt, either wrap this right around this prompt function here, which would work, or for readability's sake, do it right here on chosenMaxLife, where I then use parseInt on my entered value. So the entered value here, which is a string, is forwarded to parseInt. Now, of course, the user could have entered any kind of garbage here, for example, a string which is not convertible to a number. And therefore, here we can add a if check, and you can do that here as well, not just inside of functions, but also directly in the script, and check if the chosen max life here is maybe not a valid number. And for that, you can use a number function built into JavaScript, and that's the isNaN function, which checks if that is not a number. And parseInt will yield not a number, so this special NaN type, if you remember, if the value you pass to it, so entered value in this case, is something that can't be converted to a number. Then it will spit out NaN as a value, which is then stored in chosenMaxLife. And with isNaN, we check if that's the case. So if chosenMaxLife happens to be not a number, so this NaN special value. If that's the case, I'll set chosenMaxLife to my default of 100 so that we still have a working value for the game. We then don't use what the user entered because that was unusable. Instead, we use our default value here. I also want to step in if the user sets the life here to a negative value or to 0. So we'll add the OR operator here and check if chosenMaxLife is smaller or equal than 0. That means that I also reset this to 100 if the user entered a too low life. Now, one important note regarding the order of evaluation here. JavaScript works such that it first checks this here if you have the OR operator. And if this yields true, since OR wants one of the two values to yield true overall, it doesn't even look at that second check here. So if we have chosenMaxLife, which is not a number, it won't even try to do that comparison, which is great because for this comparison, we need chosenMaxLife to be a number. But it will not even try to do that if this already tells us that it is not a number. So that's really good. It will stop for the OR operator after the first subcondition that returned true. If you had AND here, it would always look at both because obviously for AND, both need to return true. But for OR, it stops after the first one that yielded true. So if we don't have a number with which we can work, it will not even try to do this check here. Now, in either case, we set chosenMaxLife to 100, and therefore now we give the user a chance of initializing the values here. So if I save that and I reload, now we get that prompt, and if I enter 80 here, and I then inspect these health bars, you will see that indeed max and value is set to 80 here. If we now attack, you see this decreases to lower values, and at some point, we won. Then we can start another new game and we won again because I'm spamming the strong attack. Obviously, this game is not really balanced. By spamming strong attack, you will very likely win every game, but it's more about practicing if statements than building the next best amazing game, which will win you tons of money. You will have to do that on your own, unfortunately. So that works. If I reload and I set a different value, like let's say 200, you see it takes 200 as a value here, and therefore, of course, the game takes way longer. The health bars take way longer to shrink. If I reload again and I set this to 5, obviously then one hit is enough to win. And if I set this to, let's say, -10, you said we end up with 100 because then we overwrite the user choice because of the invalid values here. Now, by the way, if we press cancel here, we also go with the default values because that also doesn't yield us a valid number in the end. So with that, we got these basics down. Now, there is certainly more we can tweak and more we will do in this section. For example, we're also not doing anything with the show log button because we're not writing a log at the moment. But the basic game logic is implemented, and we have a couple of examples for if checks, also with this special isNaN function here, and lots of combinations of conditions, lots of different checks. So our game is taking shape. The logging functionality is still missing and we'll add it soon. Before we do that, I want to show you one pattern which you also sometimes see in code, or which you might want to use if you're having a if condition where you're using some kind of identifier, as I'm doing it here with the mode in attack monster. There we got attack and strong attack as values for which I check here. Now that means that in this case, since we received it here as a parameter in this function, we need to make sure that whenever we call that function, we do pass in attack or strong attack written exactly like this. And a simple typo like this already will break our function. Now obviously we can always find and fix such a typo thereafter, but you might want to avoid code where you use string identifiers like this, where you then can mistype. Now that does not mean that you should avoid string identifiers altogether. There's just a more elegant way of handling them, and that's exactly what I want to show to you now. What you can always do is you can create some global constants. Let's say here at the top of our file, doesn't technically have to be there, it just should be done before you start using these constants. But having such global static constants at the top of your file quickly makes it possible for other developers to understand which key values this file uses, which key static values this file uses. And there we could create something like mode attack and store a string value of attack in there. Or alternatively, a number. So you could also have mode attack equal to 0, let's say. And also have mode strong attack, where you then store strong attack in there. Or if you work with numbers instead of string, mode strong attack might be 1. So a different number than for the normal attack. Now what's the idea behind these constants? The idea is that you can use them in your if condition down there and also when you call the function. Because now instead of comparing mode to a hard-coded string here, we can compare it to mode attack. So to this constant, which of course holds such a string. The idea is that we therefore only type the string once up there, and even if we do mistype here, that doesn't really matter therefore, because thereafter we only refer to this constant in all the places where we want to use this identifier, and therefore we avoid that danger of mistyping. So here I refer to mode strong attack, and therefore now when we call the function, we pass in mode attack and mode strong attack. And it's way harder for us to mistype the variable or the constant name here, because here we get some IDE support, and therefore we avoid this extra error source. So with that, our code still works exactly as before. It just should make it easier for us to ensure that we avoid dumb mistakes or dumb typos, which might cost us minutes or hours to find and fix. Let's now work on the logging functionality. And there I want to log every round that happened in the game, every event that happened in the game. So when we attack the monster, when we launch a strong attack, when we heal ourselves, when the monster hits us, and also when the game is over. And for that we can add a new function, maybe up there, which I'll name write to log, because that's what's going to happen in there. Now in this function, the idea is that we write the different events to a log, and for that we of course also need a variable that holds our log. So here at the beginning of our file maybe, we can add a new variable, battle log, and initially that's an empty array, let's say. Now I want to add entries to that array in the write to log function. For that, it would make sense to expect some kind of event parameter, event identifier, which describes the event that happened, and then have multiple if and else if blocks to check for the different events we want to support. Now, just as in the last lecture with the attack modes, which I set up as global identifiers, I want to do the same for my log events so that we avoid typos. And there I can have my log event player attack, for example, and give this an identifier of player attack or use a number instead of a string. That's really up to you. Have my log event player strong attack with a text of player strong attack, let's say. Now these texts, as well as the variable or constant names here, are totally up to you. Of course, I just try to describe what we'll use them for. And I use this uppercase only notation here to make it clear that these are static values I, the developer, define here, hard code here at the beginning of my script. Then I also want to have a log event monster attack, of course, because the monster may hit us like this. And also a log event player heal, because we might heal, and also a log event game over, something like this. Now that could be the log events with which we want to deal, and therefore now we can check for them. We can check if event is equal to log event player attack, let's say. And if that is the case, I want to add a new entry, a new object to my battle log, which holds some information about that event. So for that, I'll actually create a new variable inside of the write to log function, so which is only available inside of that function, and that's my log entry. And then here we can set log entry equal to a new object. And in that object, I want to have my event identifier, which is a human readable string. And actually, therefore, here I prefer having a string identifier as we set it up here over a number, because later when we print that log to the console, for us humans, it's easier to see which kind of event that was if we have a string that describes the event than if we have a number which we then have to translate with the help of our code to find out which event that was. So here I store the event. Then I also want to store the value for the event, let's say, so the damage caused. So that's probably also something we should get here as an argument. So I'll expect a value here, a value argument, and store that in my value prop here. And in case it's confusing for you that we have the same names for the keys as for the values here, of course you could get, let's say, ev here and a val, and then use ev here and val here to make it clearer that the key names are totally detached from the value variable names here. So now I'm storing the event, which is something like player attack, the value for that event, which for the player attack would be the damage dealt. For player heal, it would be the damage for which you healed. For game over, it could be the name of the winner, so player or monster, for example. And I also want to output the final monster health here. And for that, I can access the current monster health. Alternatively, we also expect this as an argument here, which might be cleaner. We could use the global variable, but by using an internal parameter, we make this function a more pure function, which only works with data provided to it, instead of also taking some global value, which is always kind of dirty or harder to follow if you're reading the code. It might be unexpected that a function also pulls in some information from outside, especially if it's a function that also does take parameters. And also the final player health here maybe. And for that, I also expect to get my player health snapshot here and store that. So that could be a log entry we want to create, and then we can reach out to the battle log and push that log entry onto the battle log. This is how we could add a new entry there. Now, of course, we don't just have that case that we have the player attack. We also have many other events that can occur for which we set up identifiers. So we can add another else if statement here, where we check if event is maybe equal to log event player strong attack, let's say. If that is the case, I will basically create my log entry in the same way though. So therefore, actually, we don't really need else if block here, right? Because we only populate the log entry with the data we got here. Well, that's indeed true. You could totally create that function without any if checks if log entry is always created in the same way with dynamic data that changes when you call the function but not inside of the function. To again practice if statements, I will add some extra information here which depends on the event that occurred. I want to say target, and here say monster. That's some information we're not getting from outside. Here I'll also add target monster. And then, just as before, push this entry into my log. And then add another else if block where I check if the event is equal to, let's say, log event monster attack. In which case we can also copy that code here. And here the target would be player, that's the difference. Now let's add another case, because we also might have the event that we healed the player. So log event player heal here. And therefore again we can copy in that code. The target here is the player, of course. And then we have the last else if block here. The event is that we have the game over case. And there we have no target, so I don't need to set a target here. Instead, I just have my log entry like this, where I output with the final healths. Value then in this case could be the name of the winner, so player or monster, or draw if we have a draw. And well, then we push this onto our log. Now I push to the log in every case, and therefore we can actually remove that line from the if cases here. So for all the else if blocks and for the main if block, I remove this. And instead, I can push log entry onto the battle log after the entire if block, because we know we have a log entry variable. It will hold some value after all these if checks, unless we passed in an EV identifier, which is not covered here. And then we push that entry onto the log. And that uncovered event identifier case shouldn't really happen here, because we will call that function, and we as a developer here will make sure we don't call that function with an invalid value. Alternatively, of course, you could add an extra check, and before you execute any code, check if EV is log event player attack or strong attack or monster attack and so on. And if that is not the case, so actually check if it's not that or not that or not that and so on, then you could return basically such a check, as we also added it earlier in this module in the calculator already. Here I'll not do it, but it is something you could do. Now with that, we create these different log entries here, and you could even refine this code a bit more and actually set log entry to an object here, where you do have all these fields which are always the same. Whoops, didn't want to cut them there. So everything except for target. And then here you would only add log entry dot target and set this equal to monster here, for example. So only add a new property dynamically, which you can do in JavaScript with the dot notation. If you access a property which doesn't exist yet, this will add it dynamically. So you could do that and save even more code. I will leave these other log entries here like this though, just to make it really clear that we do set this information on every if block. We do it with this other approach too, but this might be easier to read and to understand. This approach, however, where you only change the target, of course, is the more dynamic or the shorter approach, and therefore the approach you might want to use in bigger apps. Side note, if you do follow that approach where you set up that object up there and thereafter you only change the target, you can of course omit that last else if block here, because there we don't set a target, so there we already got the readily configured log entry with our default log entry up there. So that's just a side note. Creating all these extra objects is a bit redundant, but I leave it like this for readability here. Then we push that onto our log, and with that we should have a log. Now let's make sure we can also output it. And for that, in the vendor.js file, we have the log button to which we can add an event listener. So I'll do that in app.js at the very bottom here. I add my event listener for a click event, and there I want to have my let's say print log handler function, which doesn't exist yet, which we have to create, maybe right down there, the print log handler function. And in that function I want to output the log, and for now I'll just console log the battle log variable, which should be that array. Now we just need to make sure that we actually call write to log for every event that we do want to log, because right now that's not something we're doing. So let's do it. And for that, of course, in end round, when the monster hit us, I want to call write to log with my log event monster attack identifier, because the monster attacked us. The value then is player damage. And the monster health at this point then is the current monster health, and the player health is current player health. So this is how we can call this function here. We can also restructure this across multiple lines with the auto formatting shortcut to make that a bit easier to read. So that's right to log after the monster hit us. Now I also want to log when the game is over, and that of course is the case whenever we also call reset. But I need to know whether we won or lost or had a draw, so I will actually write to the log here in these checks where I do know whether we won or the monster won. And then here I will create my log event game over. The value which I now pass in is not the damage, but instead the result of the game. So here that could be player 1, whatever you want to use here. That's any text you want to put into your log message, into your log object. The health snapshots, and then do the same here for the monster if it won, so monster won, and also down there if we have a draw, then maybe output a text of a draw. In the end, you can put any data you want in there. And now we got 2 other events which I want to log, or 3 other events actually. That's when we attack the monster, strong or with a weak attack, and also when we heal ourselves. So let's start with attacking the monster. So here I also want to write to the log after we reduce the monster's health. And which event I write to the log differs based on the mode we have here. So actually, we can add a new variable, log event, and then log event is either equal to log event player attack here, or if we selected a strong attack, it's log event strong attack. And now log event is a variable that holds either of the 2 identifiers, so the string values stored in these constants in the end. And therefore now here, when I write to the log, I can use log event, this variable, which is one of my identifiers, or to be precise, the values stored in these identifiers, of course. The value which I want to write to the log is the damage that was actually dealt. And then again, I take my current monster and player health snapshot. And now there's one last thing I want to write to the log, and that is when we healed ourselves. There, after we adjusted the player health, I have my log player heal event. Then I healed by the heal value here. Heal value like this, because that's the actual heal value by which we healed. And then again, my health snapshots. So now with that, we should have all that functionality implemented. Back in the app, we can open the developer tools now to see the console. And if we now reload and start a new game and we attack and a strong attack and we heal, and then I show the log, we have 6 events in there, and that makes sense. We have a player attack where we hit the monster for a value of around 6, and that makes sense because the monster health thereafter is around 94. Then the monster attacks us for around 4 damage points, which again makes sense. Monster health is still what it had after we hit it, but now the player health is reduced by that damage here. And then we launch a strong attack with a value of 10. Monster health thereafter is 83, which makes sense. It was 93 something before, now it's 83 something. After hitting it for 10 something, player health is unchanged. Monster attacks us, so now, well, this is the damage it dealt to us. This is our health thereafter. And so on. We healed ourselves. There you see we healed ourselves for around 6, fully up to 100 thereafter. But then the monster hits us again, takes us down to 90, and that's basically what we see there. Now let's continue here and launch a couple of strong attacks until we win. Yep, we did. And now print the log. Lots of messages in there. In the end, you see the game over message. And there you see player 1 and the final monster health below 0, of course. Player health above 0. And therefore, this all works. This is how we can write to the log and how we can output the log like this. Now, later we will learn about loops and therefore how we can output this log in a bit of a nicer way instead of just throwing the entire array in there like this. But for now, this will do. And with that, we also had a lot of if usage. Now I want to dive into some of the neat features which we haven't really talked about yet when it comes to if statements, about conditional code, before we thereafter dive into loops. There is one special conditional expression which we haven't seen and used thus far, and that's the so-called ternary operator, or the ternary expression. It's important to understand that if statements themselves return no values, right? You just dump them into your code to then execute code conditionally. It's not like a function or a calculation with some operators. If statement doesn't return any value which you could store somewhere. Therefore, this, for example, does not work. You can't assign a if statement to a constant, because this will not return anything. An if statement won't return anything, and this will actually be a syntax error, therefore. This is not allowed. But maybe you have code where you want to use a different value in, let's say, username or any other constant or variable, and the concrete value you do want to save in that constant depends on some condition. Actually, that is something which we have in our code already. Here in attack monster, we have max damage and log event, and these are variables that hold conditional values. They either hold, for max damage, attack value or strong attack value based on this condition, and thereafter we use that variable. So in the end here we have a variable where we store data that depends on some condition. But I do so by first setting up the variable and not assigning any value. And then we have a if condition, which we don't try to store in any variable or constant because that wouldn't work, as I mentioned. And then inside of the if condition, we assign values to max damage in this case and to log event as well. This is valid code and this works. But this snippet here doesn't work. But it would be convenient to have some kind of if statement that would work like this, where we kind of return a value in it, and then that returned value gets stored in a variable. Would save us some extra lines of code. Well, there is a solution for that. You can use the so-called ternary operator in such cases. It allows you to have an inline if statement, if you will, without the if keyword, because that can't be used inline, but with the question mark and colon operators here. And together they make up that ternary operator. Now, the logic here is simple. You first put your condition which you want to check, and there you can have any condition you could have in an if statement, including multiple conditions combined with and or. Then you have the question mark, and thereafter you have the value you want to use if the condition is true. And that's important. You have a value here, so something which could be stored in a constant. You don't put more complex code here, not multi-line code, not multiple expressions. You can't use an if statement here or define a new variable here. Instead, here after the question mark, you need some value that could be stored in a constant or a variable in any other place as well. So which you could directly assign with the equal sign to a variable or constant. And then you have a colon, and then you have your else value, and you need to specify this. So omitting that else value is not allowed. That would be a syntax error as well. So here we have the islog in condition, which probably is a boolean or some truthy or falsy value. And if that is true, we store max in username. If it's not true, I store null in username. This is a ternary operator in action. And we can actually use that in our code as well. We can change that code to not use this if statement. And let me make it very clear that there is nothing wrong with using an if statement like this. In some cases, using explicit if statements like this might also lead to more readable code than using ternary operators. But in some cases, you also can save some extra code by using ternary operators. And for example, here we can comment out the if statement and set max damage here equal to, and now I check if mode is equal to mode attack. And then if that's true, separated by a question mark, I assign the value to max damage that should be used if mode is equal to mode attack. So basically attack value here. And otherwise, separated by a colon, I use the else case. So in this case, strong attack value. And now we set that variable to either attack value or to strong attack value based on this condition. So on this condition, if mode is equal to mode attack. Now, of course, since I therefore never reassign a value here, previously we did do it because we assigned values in the if statement. Now we initialize this variable with a value right away, thanks to this ternary expression. We can also switch this to be a constant because I never assign a new value. We never use the equal sign after max damage again in this function here. And of course, we can do the same for the log event. We can also switch this to a constant and now assign a value based on this check here. So check whether mode is equal to mode attack. And if that is the case, then we have a value of log event player attack. Otherwise, we have a value of log event strong attack here. We can also structure this across multiple lines like this. I did this with the auto formatting shortcut. As you see, it's no problem. As always in JavaScript, you can write your code along multiple lines here. JavaScript then finds out where this ends with the help of the semicolon here. So with that, we removed that if statement and we saved some extra code here. We are able to initialize these constants right away, and therefore we are able to use constants instead of variables. And as I mentioned, this is now not strictly better than using the if statement. Absolutely do use the if statement, especially if you had more complex conditions here and more complex values where you maybe also run some calculation first of all. So where you then all of a sudden have very long lines of code, then you might actually prefer having an if statement where this is more structured and readable. If you have relatively short conditions and value assignments as we have it here, however, then using the ternary expression is a fine alternative that can save you some extra code. Well, and with that, we should see that if I reload here and I start my game, that still works as before, but now with the help of the ternary expression. It's also worth noting that a ternary expression can also have nested conditions. So here where a value is expected, you can have some other check and then have a nested ternary expression where you then have the nested value and the nested alternative value here. But you should use that with caution because that can quickly lead to very hard to read code. And using a real if statement with else if blocks often is the better alternative to deeply nested ternary expressions. Nonetheless, it does work, it is supported, and it is something you can use, especially if you have short code, short conditions, and it's not getting unreadable. It's time for a little bit of behind the scenes theory about JavaScript code and how we call things there. You might have heard me say things like statement or expression. Well, there actually is a difference. This here is an expression. Basically, in JavaScript, an expression is something that yields a value you could store in a constant or a variable or return in a function, something like this. That's an expression. Now, every expression also is a statement. This here, for example, is also a statement. But an if statement, on the other hand, is just a statement, not an expression, because you can't use it in the places where you, for example, just need a value, as you just learned. You can't do that. Instead, an if statement here can only be used in code like this. You can't use it on the right side of an equal sign, basically. And therefore, this is a statement, but not an expression. So you could kind of memorize that an expression is basically something which would work if you use it on the right side of an equal sign. It's not super important for you to learn it by heart. I just want to clarify what I mean when I say expression or statement. And as you see, most things in JavaScript are expressions, but something like the if statement would be a statement. We will also see other statements later when we dive into loops, because these also are statements then. But for now, the if statement is the important statement, which is not an expression, which we learned about thus far. Now that we learned about ternary expressions, I also want to show you some other specialties you have in JavaScript when it comes to expressions and to conditional code and logical operators. And I can best show you this in the console because in our little project here, we have no real use case for the things I'm about to show you. I want to show you some nice tricks or shortcuts with logical operators. One important trick is how you can convert or coerce a truthy or falsy value to a real boolean. You do this with the double exclamation mark, also called double bang operator. Now we learned about the exclamation mark operator, which is there to negate some condition or a value. And by using two exclamation marks, you basically negate the negation, which kind of reverses the negation. But there is one important thing. The exclamation mark, so the single exclamation mark already, converts a truthy value into a real false value. And if you then convert that false value back with another exclamation mark, you could get a real true value, so a real boolean. So for example, if you use double exclamation marks in front of an empty string, you will get a real false boolean instead of that falsy interpretation which JavaScript normally uses. If you use double exclamation marks in front of a 1, you get a real true value. Now often it might not matter to you, but whenever you have code where you want to work with real booleans instead of let JavaScript do this truthy falsy comparison or coercion, then you can use the double exclamation mark to get such a value. So it's basically a type conversion trick which can convert an empty string to false or any number to true, things like that. And sometimes in code, in more advanced programs, typically you might need that, and then this is a convenient and handy approach. Another nice trick, if you want to call it, is related to how JavaScript works with the OR operator. You can use it to assign a default value to a constant or variable. So you learned about that OR operator, of course, and as I just said, you can use it to assign a default value with this syntax here. Now what does this do? This will check some input. And now imagine that some input is another variable or constant that holds some user input and that might be empty. Now remember that empty is a falsy value, an empty string is a falsy value, is treated as false. And the way JavaScript works with the OR operator is such that it has a look at the thing in front of the OR operator, so it's some input, and if that is false, it will also have a look at the value after the OR operator, because it will return true overall if at least one of the two things in front or after it is true. And of course, the thing after the OR operator here would be true, right? Max is a string which is truthy. It's not an empty string, therefore it's truthy. So this will basically yield true overall. But now that's the important thing. Unlike our logical operators like the triple equal sign or the greater or smaller operator, the OR and the AND operator don't generate a boolean. You can use them to combine conditions and then they will return true or false, but not because they create true or false, but because they return the results generated by the conditions they are combining. Now, if you're working with two strings like you're doing it here with some input and max, and I'm assuming that some input also holds a string, what happens here actually is that OR will return the first truthy value without converting it to a real boolean. So it will keep the original value and return that. And in our other comparisons, like this here, for example, well, that generates a real boolean, that generates a real boolean. That's why OR returns a real boolean, because the things to the left and right of it generated real booleans, not because OR generated a real boolean. This only just returns the first truthy or true value it's looking at. And it starts from left to right, so if this returns true, it will return this true value and not even look at the second one. If this returns false or is a false value, it will look at the second condition, and if that then returns true or is a truthy value, it will return that value, either a boolean, as it would be the case here, because this operator generates a boolean, or, as in the case of this slide here, max, if some input is falsy, because max will be truthy and it will therefore return max. The AND operator allows us to do something similar. Instead of using it to assign a default value, we can use the AND operator to get the last value in a combined check like here. Let's assume that is logged in here is a truthy value or a real true boolean, doesn't matter, but that it is true. In that case, and will return the last value it's looking at. Because and, unlike or, always looks at all, so at both values in front of it and after it, because all need to be true or truthy. And if both are true or truthy, it will return the last value. If the first value is true, it always returns the second value, or the value after the AND operator, I should say. If the first value is false, it will always return the first value. So here, we would return max if isLoggedIn is true, and null or false, or whichever value is stored in isLoggedIn otherwise. Now, as I said, let's have a look at that in the console. Let's start with the double exclamation mark operator. Let's say we have some user input here, and that's an empty string. We got that from some input field, but the user pressed the OK button without entering anything. That's a use case you can have in web applications. You will actually have that a lot, that users enter incorrect information. Now, let's say we want to use that somewhere in our code, and in the end, in multiple places of the code maybe, I just want to know, did the user enter something valid or not? So, of course, we could always check for user input, and this will be false because it's an empty string, so we could do something in the else block here. But maybe we want to use that is valid or not information in multiple places, so I create a new variable, is valid input, and that should be true or false based on user input. Then, of course, we could write user input and use this as a condition in a ternary expression, and after the question mark, we could therefore say true, because if user input is truthy, then we want to store true in is valid input, otherwise we want to store false. We could do that, but the shorter way is to just use the double bang operator here and say this, because as you learned, this translates it to a real boolean. So in this case, since it's an empty string and therefore falsy, this converts it to a real false value, to a real false boolean, as you see here. A single exclamation mark would also convert it to a boolean, but of course to the opposite boolean, because a single exclamation mark negates the value. So if it's falsy, it's turned to true. If it's truthy, it's turned to false. So if we want to keep the original meaning, so a truthy value should become true and a falsy value should become false, we need two exclamation marks to not negate it, but to instead just use this as a shortcut to convert the type. Let's now have a look at default values. Let's say we want to create a username here, and that's based on some user input, which of course is an empty string. We just set this up before, and if you clear here, the old values are kept, you just don't see them here anymore, but user input still is set, as you see if you want to output it like this. So now we want to create a username here based on user input, and now we either want to use the user input, but if that is falsy, so if it's empty, I want to use a default value of max, and we can do that with the double pipe symbol, so with the OR operator here, because now, as you will see, we'll have max stored in there, because user input is falsy. Of course, this would also work if it was a real boolean that's false, and therefore this is used. If it would be truthy, so if we have, let's say, the real user input, and that is menu, and then we set real user name equal to real user input or max, then real username will actually have menu stored in it, because that is a truthy value, and therefore in this check or returns that first true or truthy value, which is the real user input, and does not use this as a default value. So this is how you can use the OR operator to assign default values to variables. Now, of course, you can also have more than one OR operator here. If you had multiple variables that might or might not hold a true value, you can have value 1 or value 2, or, and then at some point, some hard-coded default value, which you define probably. Now let's have a look at the double AND operator. For that, let's say we have a isLoggedIn variable, which is true. And based on that, we want to store some other value. Let's say we have the shopping cart, and that's some data which we loaded from a server. And if isLoggedIn, then we want to initialize this to be an array which already has some books in it, something like that. If we run this, you see now shopping cart indeed is that array with the books in it, because is logged in is true. And as I said, if that's the case, then the double ampersand, so the AND operator, will have a look at this, then have a look at the second value, and if both are true, it will return the second one. And an array, no matter if it's empty or not, always is treated as a true value, which is why it returns that. On the other hand, if we set is logged in to false, you will see that now if you set is logged in and books, and of course we could store this in a variable or just output it like this to see what would be stored in a variable, you see that this now returns this false value that's stored in is logged in. Or if you had something here which is null, it would return null. So it basically returns the first value here. So here, for example, it would return null if we have that. So it returns the first value if that is false, the second value if both are true. Now what if the first is true and the second is false? Let's have a look at that as well. So here I set is logged in back to true, let's say. And then we check if is logged in and then something which is false, an empty string maybe, then it also returns this. So if the first value is true, it always returns the second value. If the first value is false, it always returns the first value. Now these shortcuts, these tricks might be a bit confusing, also because we have no real use case for them in this project. We will see them in some places throughout the course though, and you will also see them in projects you work on. Now be aware that these are always just shortcuts. What we do with them can always also achieved with the help of full if statements or with ternary expressions, but sometimes it's just shorter to use these shortcuts. That's the main idea. So if you forget to use them in a case where you could have used them, that's not bad. You will not have an application that's way slower or worse or anything like that. These are just alternatives which can save you some code, and you can always refactor your code to use them if you find a place where you can use them. But it's absolutely normal that you also sometimes overlook scenarios where you could have used one of these shortcuts. I just want to make you aware of them right now, so that if we do later use them in the course, you are aware of them, and also that you recognize these patterns if you see them in other code or in other examples. Now last but not least, to conclude that if statement part, I want to introduce the switch case statement, which is a new statement but kind of related to if statements. It's great in situations like this, where you have multiple equality checks, because that's where it really shines and where it is the most helpful, where you want to execute different code based on the condition that was met. Now you can also use switch case statements with other conditions where you don't check for equality, but there you save less code and they often are harder to read. So you typically use switch case statements, or you can use them as a replacement for if-else if statements with a lot of else if cases if you always check for equality and you're just checking multiple different values. So let me show you how you could translate this long block of if and else if blocks into a switch case statement. For that, you use the switch keyword, which is built into JavaScript, and the switch keyword doesn't take a condition, but it takes a value, a single value. So in this case, the event. Then you add curly braces and no semicolon after them. And then you can add the case keyword to define a case. The case now is a concrete value that could be stored in this variable or constant, or in this case, parameter. So for example, here, log event player attack. Of course, you don't have to use a constant here which holds the value. You could hard code it in here. Doesn't have to be a string either. You could be looking for a number. But by default, this looks for equality here. Now, if you're interested in some ideas of how you could use a switch case statement with greater than and so on, you will find resources attached to this video. But this is the most straightforward way of using it, the easiest to read way, the way for which it was invented, I would say, and the way where I would use it. If you have other conditions that include more complex conditions, greater than and so on, or combined conditions, I would always go for an if statement. If you have an if statement like this though, where you always have only one condition and you check for equality, then a switch case statement might be an idea. So how do you use it? You see I added a colon after this case definition, And then typically in a new line, you define which code should be executed if this case is met. So if EV has a value of log event player attack. Also worth pointing out that behind the scenes, Switch always uses the triple equal sign operator to compare that. So it only will go into that case if the event holds log event player attack, both regarding the value but also the type. So if event really is a string in this case, because that's what's stored in log event player attack. So now we have that case defined. Now we define the code that should be executed if that is the case. So in this case, I want to adjust my log entry target. And then you can define a second case. In this case, a case here that the value stored in EV is log event player strong attack. And then again, colon, and then the code that should execute. So either you again just manipulate the target, or as I do it down there, you create a brand new object which you store in log entry. Now, very important, you also should add another special keyword after each case, and that's the break keyword followed by a semicolon. Now, we haven't seen the break keyword before. It's a keyword built into JavaScript. And in the end, what it tells JavaScript is that if that case has been handled, no other case should be handled. Because by default, Switch case statements do something which is called fall through, which means if you made it into that case, then that case would be executed as well. Because the default behavior is actually that if it made it into a case, it will also execute the cases below it automatically, even if these don't match the value. Sometimes this is exactly what you want. Sometimes you want to have the same code for multiple cases, and you could achieve that by not defining any code for a case. Then, thanks to that fall through mechanism, if this case is met, it goes right to the next case and executes this code. But in other cases, you only really want to execute one piece of code for each case, and then you add the break keyword to tell JavaScript, after this is finished, don't evaluate any other cases, just leave the switch case statement, we are done. So now let's also add break here, and then, again, add another case, and that would be the log event monster attack. So let's add this here, and thereafter that code which we had in this else if block. And then add yet another case here. Now here for the player heal. So let's add that here. Also don't forget the break statement here. I did forget it, so make sure you don't. So log event player heal. There, of course, I'll grab this code, which I have down there in the else if block, add it here below case and add the break keyword. And then add the last case, and that's our event game over. So let's add that here, like this. Also, of course, copy the code we have down there, add it here, and maybe also add break here. Of course, here, though, you could omit it because we have no other case below it. Now, in switch case statements, you also have another special keyword, and that's default, followed by a colon. That allows you to define some default code in case no case is met, and therefore you make it into no entry point here. Then you would add default to still execute some code maybe in case no other case is met. So here we could set a log entry to an empty object, for example. Now, of course, that means that now I can comment out the if-else if statement here and just keep my battle log push code line. And with that, we have a valid switch case statement. Now, is that better than if and else if? Well, if you have such strict equality comparisons, it can be a bit cleaner to read, and therefore it's a real alternative, which I tend to prefer. But ultimately, you can also stick to if, else if you prefer that, if you find that easier to read. And especially if you have more complex conditions, multiple combined conditions, or greater than checks and so on, you definitely want to use if, else blocks and statements instead of the switch case statement, because that really only shines for strict equality checks. After all these if statements, which are extremely important, which is why I spend so much time on them, because you will basically need them in any program you write, So after the if statements, it's now time to come to another very important construct in JavaScript and in actually any programming language, and that would be loops. In programming, you often have the scenario that you need to execute certain code multiple times. Now, you might think, okay, we have functions for that. We can have reusable code in there. We can call a function multiple times. Sure, but in your code, you have to write every function execution, right? Of course, you can attach a function to an event listener, and then whenever that button, for example, is clicked, the function executes. But if you want to control that a certain snippet of code runs for every item you have in an array or runs 10 times, then you would have to put 10 function executions, for example, into your code. And loops allow you to write such code repetition in a more dynamic and flexible way. Now in JavaScript, we have 4 main loops, and that's the for loop, the for off loop, the for in loop, and the while loop. And for the while loop, we also have one variation, which I'll also show you. Now, what's the idea behind each of these loops and when do you use them? The for loop together with the while loop is the oldest loop. It's been in JavaScript forever. And the for loop allows you to execute code a certain amount of times. And you use a counter variable for that, which you typically increment or change with every loop iteration. So that means that with a for loop, you can easily define that a certain part of your code should run 10 times, 20 times, a million times. Here's an example. This is how a for loop looks like. You have the for keyword, then between parentheses you initialize or you set up that loop, and that consists of 3 parts. Begin phase, where you initialize variables you can use inside of that loop. So between these curly braces, and that's important, the variables set up there are really only available inside of the loop. Then we also have separated by a semicolon, so not by a comma, not by a colon, but a semicolon. We have a condition, an exit condition, which basically defines when we stop executing that code between the curly braces. And then we have, separated by another semicolon, the code that should run after every loop iteration. And there you could do whatever you want, but typically you just change that variable which you initialized and which you also use in your exit condition. So this loop, for example, would initialize I, and I is a name which is often chosen. It stands for iterator. So you choose I and you set it to 0 initially. Then after every loop iteration, so after this console log body ran, it's incremented by 1. And then before the next loop iteration, before every loop iteration actually, this condition I smaller 3 is checked, and the loop body is only executed if that condition yields true. Which of course means that in this example here, we would print the values 0, 1, and 2, but never 3, because after the 3rd loop iteration, I gets incremented to 3. Before the next iteration, this condition checks if I is smaller than 3, which of course is not the case if I is equal to 3, and therefore it would stop executing that and move to the next line of code after that for loop. That's how a for loop works. And of course, needless to say, we'll see that in action right after this lecture. Now, another loop you have, which is a bit newer, but now also very well supported in JavaScript, and that's the for off loop. Now, that executes for every element in an array. It allows you to execute code for every element in an array. It looks like this, kind of like the first for loop, but a bit different. Between parentheses, we don't have these 3 parts. Instead, here we have the off keyword, and we create a constant. Could also be a variable, but typically you create a constant, which gives you access to one element of the array at a time, and then this body between the curly braces is executed for every element in the array. And L in this case then refers to that element in the array for this current iteration. And this is convenient for example, doing something with every element in the array or outputting it to the console or whatever you want to do. Now, for off helps you with arrays. We also have for in, and that allows you to execute code for every key in an object. This is how it looks like. And there we basically have the same syntax as in a for off loop, but with the in keyword instead of the off keyword. And an important difference is that for off is built to work with arrays, for in is built to work with objects. And there you get access to every key in the object. So that's the part on the left side of the colon when you create these key value pairs in objects. And then this second line you see here, console log object square brackets key, that's actually a syntax we haven't used before. This is a way of dynamically accessing key value pairs in an object when you don't have the key name, but instead you have a variable or a constant that holds the key name. Then this gives you dynamic access to the value stored for that key in the object. And of course, we'll also see that in action in this module. Now, last but not least, we have the while loop. The idea behind the while loop is that you execute code as long as a certain condition is true, and only if that condition is somehow set to false, you exit out of the loop. It looks like this. The idea here basically is that you don't really work with a counter, though you could also do that here if you check the counter in your condition, but that you maybe have some boolean which you then change at some point of time inside of your while loop, and you continue executing code until this is done. So these are the different loops. Let's now have a look at them and see how we can integrate them into our project or generally work with them. Now, I think a great place to work with the loops is at the bottom of the app.js file, our nice little print log handler. Right now here, I print the entire array like this, which means that we get output like this, which is not super readable. With the loops, we can actually improve that because now we can loop, for example, through all entries in the battle log and output something nicer there. But I'll actually start with another loop, and that's the normal for loop. I say normal because that is the oldest for loop, and that also is a syntax you find in pretty much any other programming language. Not necessarily the case for off and for in, but for like this and the while loop, you will find that in 99% of all programming languages you can learn. So a for loop is created with the for keyword, then with parentheses, and then you have these three parts in there. The first part is a part where you initialize things for the loop. You could run a lot of different code here, basically any expression, so anything but an if statement or another loop can be executed here. You could call a function in here, but typically what you do here is you initialize a variable. You could initialize multiple variables, but in most loops you only need one, and that's that helper variable which you change after every iteration to execute code. So here I'll go with the classic example of initializing I to be 0. By the way, that should be a variable created with let because it will change in every loop iteration, so therefore it's a variable, not a constant. Then you have your exit condition, which is evaluated before every loop iteration, and there we could use that example from the slide with I smaller than 3, which means the loop body will only run if I is smaller than 3, which of course is the case initially since I is 0. And then separated by another semicolon, you have the code which you want to execute after every code execution. There you can do whatever you want. You could also omit this by just having a semicolon and nothing thereafter. Side note, you can omit every statement here, then you would create an infinite loop. You need the two semicolons here though. Now you would have a loop that runs infinitely, which is something you should be careful about because it can crash your browser since it clutters up memory and takes away all resources. But you could do that. In some rare cases you might need that. Here I don't want it, so I will stick to the old syntax, and I will also provide a third part here, and that's my code that runs after every loop iteration, and there I will increment I by 1. Again, here you could do different things. You could also say I plus 2, or I minus 3, so you don't have to increment it, but that's the most common use case, that you have a counter which you increment by 1, and you have some exit condition. You can of course also use values here which are dynamic. For example, here we could use battlelog.length. The length property is available by default on arrays, and this gives you the amount of items in the array. And this is actually a quite common way of going through all items in the array if you don't want to use the for off loop, which is a bit shorter. But if you don't want to use it, because you have to support very old browsers, for example, but more on that in the browser support module later in the course. But then you could use this and dynamically derive the length here, and therefore go through all elements in the array by simply having a loop that runs as long as you have items in the array. So that's just a side note here. I'll hard code free, and then for now just console log, let's say, a couple of dashes here, so that essentially we should print 3 lines of these dashes here when we run print log. So let's save that, go back to the browser and reload, maybe perform one action and then click show log, and indeed you see 3 lines. You don't really see 3 lines here because my browser, the browser developer tools, automatically combine similar outputs, but you see the 3 here, which means it would have printed that 3 times. It just did merge it together into one output to save some space here. But it printed that 3 times. Now you might wonder why 3 times when we only execute this code as long as I is smaller than 3. Well, keep in mind that we initialize it to be 0, then we check this, then this code runs, then we increment it to 1. So we printed this once thus far, now I is 1, still smaller than 3, so we print this again, we increment I to 2, so now we printed this 2 times. Now I is 2, still smaller than 3, so this condition gets checked and is true, so now we print this a 3rd time. Now thereafter we increment this to 3. Now for the next iteration, this gets checked at the beginning as always. I now is 3, is no longer smaller than 3, therefore we exit out of the loop, but until this point we printed this 3 times, which is why we see the 3 here. So that's the normal for loop. Now, as I said, you can configure this in a broad variety of different ways. For example, you could also have a for loop where you start with I being equal to 10, and you want to go as long as I is greater than 0, and then you decrement I for every iteration. And then maybe here we console log I. You could do that too. You have a backward counting counter now. If you do that and you click show log, we see 10, 9, 8, and so on all the way up to 1. We don't see 0 here because our exit condition is that I should be greater than 0. So for I equal to 0, this will never run. But this is also something you can do. And it really depends on which app you're writing and which use case you're having, which kind of for loop you want. This by far is the most common scenario, that you start at 0, that you increment, and that you then have a hard-coded or dynamic exit condition here. So either hard-coded like this or dynamic with something like battlelog.length. So this is also quite common to have an array length here as an exit condition. But theoretically, you can initialize I to whatever you want, have whatever condition you want to have here. Of course, also combined conditions are possible. And you can also adjust I or whatever you want to do here in whichever way you want. You also don't have to adjust I here. You could leave this empty, as I mentioned, and instead adjust I in here. That would also be possible. You could do that, for example, if you want to adjust I before you do something with it. Because normally this part here after the last semicolon runs after your code here, so after your loop body. If you want to do the adjustment before that runs, you can omit that last part and manually adjust like this. And now you will see if I reload here and I cancel and click log, now we count down from 9 to 0 instead of 10 to 1, because now we increment I before we print that. So that's all possible. You have a lot of flexibility there, and I can only encourage you to play around with that. For now, I'll leave it at that because we could spend hours just trying out different combinations here. But that being said, this is the most common scenario. And instead, let's move on to the for of loop now. So we print that nice separator here 3 times, even though in the IDE we really only see it once, but theoretically we create it 3 times. Now let's say thereafter we really want to output something for every item in our battle log. Now as I explained, we can't do that with the normal loop here. And here we can reuse I because it really only exists for that loop. So not even for the entire function, but only for that loop here. So we can reuse it in another loop. That is possible. And then here we can go all the way up to the length of our battle log array, increment I, and then here we could console log battle log And then you learned that you can dynamically access an element in an array with that square bracket notation, and then you provide the index of the element, which is 0 based. But of course here we don't hard code the index, but instead we use I as an index, because that allows us to access the ith element for every loop iteration. So for the first iteration, where I is 0, we access the element at index 0, which is the first element. Then we increase this to 1, assuming that we have a length that is greater than 1, so more than one element. So then we have I equal to 1, so we access the element at index 1, which is the second element in the array, and so on. So now if we remove that console log statement at the bottom and I just leave this here, if we now reload again, and then we maybe attack, strong attack, attack again, and show the log, now you see the log looks different because now we're printing every element on its own. We're doing this because of that for loop where I go all the way up to the length of my battle log, and then I console log every element on its own instead of console logging the entire array as we did it before. So this is something we can do, but as you learned, there is an alternative if you want to go through all elements in an array, and that's the for off loop. There you work with a constant instead of a variable with let. You could use let, but using const is better because unlike this for loop, I will not change. Instead, you get a new constant for every loop iteration. So behind the scenes, JavaScript will create a brand new constant for every loop iteration. Not alter the previous one, but create a new one. And therefore, you can use const because it will never be altered. It will just be recreated. So basically, it's dumped after a loop iteration, and then for the next iteration, a brand new one is created, you could say. So we're also not redeclaring an existing constant, but we're really just getting a brand new one and the old one is dumped. Technically, it has something to do with the scope where this is created, but that's something we'll have a closer look at in the next course module. So for now, just keep in mind that this gets dumped after every execution and we get a new one. You can give this any name you want, just as you could use any name up there which you wanted. You don't have to use I, it's just a convention to use I. Here we could go with element or log to describe what's in the array, and we do have log entries here, so we could name this log or log entry. And then you need the off keyword, and then the name of the array which you want to go through. And this really only is available for arrays, and you can't use it on variables that hold numbers, for example. It works for strings because strings are kind of like arrays of characters. More on that later in a separate module, but it doesn't work for numbers or booleans or objects. So here we go through battle log through this array. And log entry now is a constant which, as I said, gets created for every loop iteration. So between the curly braces, we can now use that. And here again, we can output log entry, for example. And if we do that, if we output log entry like this, what happens is that if we reload this app and we attack and strong attack, we get the same output as before, unsurprisingly, because we're going through all elements in our array, get access to it in the log entry constant, which exists for the lifetime of this iteration, and then output it. So it's basically the same as we had here, but of course it's a bit shorter, and it takes advantage of this special for loop that was built specifically for going through arrays and getting access to the elements in there. Now, one important side note here. With this approach, by using the old for loop, you automatically have access to the index of every element as well, because I is just the index. With this syntax, you have access to the element, but not to the index. You don't know which index this is at. You could manually get access by defining a variable outside of the for of loop, which starts at 0 because your index starts at 0, which you then increment in every iteration. And then here, this would be your index, but you have to manage this on your own with the extra variable. The for of loop like this doesn't give you access to the index. So now here, you will see if I add some entries and I log this, now we have the index being printed after every entry, but again, we have to manage this manually if we need it. Now we saw the for loop and the for off loop. Now there also is the for in loop for going through all the key value pairs in an object. Now, I also want to do this here in the print log handler because there in the for off loop, log entry actually is an object, right? It's this here, and this is a JavaScript object. And you can have loops inside of loops, so you can have such nested loops. You can have a normal for loop in a normal for loop, you can have a normal for loop in a for off loop, you can have a for off loop in a normal for loop, so you can mix and match them as you need. You can also have if statements inside of for loops and for loops inside of if statements, and the same is true for while loops. So you can combine these structures and these concepts as you need to. That's also very important to understand. You are not limited to only using for loops or any loop on the top level of a function. You can use them outside of functions, inside of if statements, inside of else blocks of if statements, inside of other loops, and if statements inside of loops, and so on, as I said. So you can nest these structures as deep as you want. So here, for example, I want to adjust my output here, and I want to console log a little string identifier where I use the backticks to dynamically inject the value. Then I'll add a hash symbol, a hashtag, and then this $ curly brace syntax to output the index. So that's basically just giving me the number of this log entry starting at 0. And then I don't want to console log the entire entry like this, but instead go through all the entries in there, all the key value pairs in there, by adding such a for in loop. It looks a lot like a for off loop. You create a constant because just like with the for off loop, this variable, this constant is recreated for every iteration. And then here we get access to the key. You don't have to name that key. You can name it whatever you want. You could name it property, whatever you want to name it. I'll go with key. Then you use the in keyword and then your object, either created in place, just as you could create an array in place here if you wanted to, or more often, you refer to some variable or constant which holds an object. So in this case, to log entry. And then you have curly braces and your loop body. Now, of course, the implication of having a nested loop like this is that this outer loop will run, and then for every iteration of that outer loop, that entire inner loop will run, and only once this is completed, the next iteration of the outer loop will kick in. So that's how these two loops will work together. Inner loop has to complete for the next outer loop to continue, and then a new inner loop is started, and so on. So now here, we can console log the key value, for example, and key here really is the name of the key. So event, final monster health, final player health, target, and value. These are the keys, and that's what is stored inside of the key constant. And if we now also want to get access to the value for that key, well, then we have to use a different syntax. Then we can also console log this, but here we need to refer to our object, so log entry. And now the dot notation won't work, because if we type dot key here, JavaScript will try to find a key, a property, named key in here. And there is no key property. We only got these 5 properties here, event and so on. So there is no key property, no property with the name key. Because key is the name of this constant, not of a property in the object. But the value of that key constant then is the name of a property of this object. So the value here in key will be event, and for the next iteration, final monster health, and thereafter, final player health, and so on. So for our object, we want to access the property with the name event and with the name final monster health, and so on. And these names are stored in key. So what we want to tell JavaScript is that it shouldn't use key as the name, but the value stored in key as a name. And we do that by using a different syntax for accessing properties, which we haven't seen before for objects, and that is that we use square brackets here. Now we don't use it as we use it on an array, where we use 0 and 1 and so on, but instead here you can enter a property name. And you could hard code it like this to access the property with the name event. So this would be similar to dot event, but you can also pass in key here, and JavaScript will then extract the value stored in this constant and then access the property with that name on log entry. And therefore now in this inner loop, we will now log the name of the property and then its value. So a lot of talking, let's have a look at that. Let's reload, strong attack and show the log. And now what you see here is a lot of output. We have this hashtag 0, which means it's the first log entry. And then we have event and its value. And then the value property and its value. And the target property and its value. and so on. And then, because I never change I as I just see, we would need to increment this. Forgot that, accidentally deleted it. So therefore we still have hashtag 0 here. That should be hashtag 1 with the updated code here. But then we have the next log entry with different values for the properties. Now, of course, that's not super readable, but of course we can change this. For example, we could add string interpolation here to output a readable string, where we then first output the key, and then maybe such an arrow here with the equal sign and a greater sign. So this is just some text, so not something JavaScript tries to parse. It will just create some text here, and then output the log entry value for that key here. And now that should be more readable if we do it like this, and we reload, and we attack, and strong attack, and show the log. Now here, if we maybe expand this a bit, with the first log entry here, then event with its value, value with its value, and so on. Second log entry with index 1, and so on. So this is how we could now output our log. If that's more readable or not, I'll leave that up to you, but it shows you how you can use the different loops here, and how you can also use loops inside of loops, and how you can use a for-in loop to go through all keys in an object and still get access to the values that are stored for these keys. Now, what about the while loop? I have no great place to squeeze it in here, though I will say you can also use a while loop to replace a for loop. So if we would want to replace this, we would have to manage the variable manually. Now, since I use I down there, I now have to use a different name, because now we're initializing it in the function, and there we must only use each name once. So here I'll go with j, initialize this to be 0. And then we can add a while loop with the while keyword, then a condition between parentheses, and then your loop body. Now, if you put something like true here, this is obviously always true, and therefore this would give you an infinite loop, which you want to avoid because it will crash your application. Instead, here we could check if j is smaller than 3, and then here we can console log our code from up there, so these dashes here, and then simply increment j, and now we manually replicated this behavior. Though I will say, if that's what you want, you would go for the for loop. This is just so that we can have a first look at while. So if I reload, strong attack and show the log, we see our dashes here 3 times just as before. But again, you wouldn't really use while for that, you would go with the for loops. So let me quickly comment that back in and comment out the while loop. Now, a more realistic use case of such a while loop might be that you create some dynamic value in there, and at some point of time you want to stop. Let's say you're generating random numbers, and I'm doing this here in the browser console, so I create my random numbers variable, and you have another variable finished, which initially is false. And then you write your while loop where you check for it not being finished, so with the exclamation mark, because this has to return true to make it into the body. And then you place your cursor between the curly braces, you hold shift and press enter. Now you can write multi-line code here, because pressing shift without enter executes the code. Don't do this yet, because then you'll have an infinite loop and you'll have to close your browser and reopen it to get back to work. So now we have that while loop, and in there I now generate a random number with math random. Haven't used that before, but this gives you a random number between 0 and 1. Again, hold shift, hit enter to enter a new line here. Add it to your random numbers here. So random numbers push, random number. And now let's say we're done in another new line with shift enter. If random number is greater than 0.5, which will take maybe just 1 try or 10 tries, it's random. So if random number is greater than 0.5, then again, curly brace, hold shift, hit enter. Then in here, I want to set finished to true, which means then this condition will no longer be true, and therefore we shouldn't execute this loop anymore. At this point of time, I then also want to console log my random numbers. So if you now hit enter, this executes, and you see here, it does execute for me with 4 numbers that are generated, and this was the number greater than .5, after which it finished. If I repeat this code by pressing the up arrow here, which quickly recreates the code we just wrote, so the up arrow key on your keyboard, and I hit enter, well, now it doesn't even execute because finished, of course, was set to false, to true. So let's set finished back to false here actually. And then thereafter, by pressing the up arrow key multiple times, go back to the while loop, hit enter again. Now it took 5 tries. We have 5 elements here. Though that's not entirely correct. Of course, it used the old array and just added 1 element, so it actually took only 1 try. Let's do this again. Let's set finished to false, and let's also reset the random numbers array to be an empty array. And now repeat while. Now this took 2 tries here in my case. Of course, how many tries it takes will differ for you, but this is an example where you might use while because you don't know in advance when you will be done. You don't know how often this will need to run because the exit condition is derived inside of the loop code. Now there also is a variation of while, and that's do while. For that, I'm back in our code here, and I'll bring back this while loop with j, and there we created these 3 dashes. Now, if I log j instead, let's see what that yields. If I save that, open the console in the developer tools and reload the page, and then press show log, we see 0, 1, and 2. The same we earlier had for the for loop, which makes sense. We start at 0, check this condition, 0 is smaller than 3, so we print this, increment this, now we have 1, smaller than 3, we print this, increment this, now we have 2, smaller than 3, and for a third time we print this, the value currently is 2, which is the latest value, the most recent value we see here. We increment this, value now is 3, this is not fitting our condition anymore, so we exit by that time. So this works as expected. Now let's say you actually always want to execute your loop body before the condition is checked, because at the moment the condition is checked before the loop body is executed, maybe you want to do it the other way around. Well, then you can use a do while loop. For that you can cut your body here and then add the do keyword and add your body here. And then typically you move while right after the closing curly brace, though technically it also works if it's in a new line. What this does is, it now executes the body first, and thereafter checks the condition. If you now save that and you reload and you press show log, you see we print the same as before, because we still exit after this is equal to 3. But you'll notice a difference if you, for example, set j to 3 initially. If you do that with a do while loop, and I reload here, and show log, you still see 3 being printed here. Now if we go back to the other while loop without do, so by cutting this and removing the do keyword, if we do that here, then you will see that now actually, if I reload here and press show log, we don't see the 3 here. The reason for that is that 3 of course is not smaller than 3, and here we check the condition first, but with do while, in which case, by the way, it's also common to add a semicolon after while, not a must do, but you typically do it in this notation, not after the normal while loop, but that's just a side note. But the important thing here is this code runs first and thereafter this is checked, so that's why we here see 3 being printed if we initialize j to be 3, because this condition, which actually finds out that we don't want to continue for j being equal or greater than 3, is only executed after we first ran this loop body. So that's while and do while. You typically will use for loops more often. While loops are kind of niche. There are some use cases where they're really great, but for the majority of use cases, you typically work with for and for off and for in loops. That just happens to be the case, the way we write programs and what we want to do in there. But it's good to have while loop, especially if you have some condition which changes inside of the loop and you don't know in advance how often you want to execute that loop. Then while loops can really shine. Now, to conclude that part about loops, I want to dive into 2 important keywords which can help you control your loop execution. And that's the break and the continue keyword. We saw the break keyword already in our switch statement. There we have break to avoid that fall through mechanism. We can also use break inside of loops to leave the loop execution, to stop the loop execution earlier than it normally would. So to kind of cancel the loop execution. How does that work? Now let's say we only want to output one log entry. Well, of course there are various ways of achieving this, but one way would be to simply add a break keyword here. Maybe after this I++ thing. Doesn't really matter for this example though. Now what this will do is it will tell JavaScript, and it works in any loop, by the way, not just in for-off loops, but in all loops I showed you. It tells JavaScript, stop this loop execution. Of the loop I'm calling this in. So if you're calling this in a nested loop, it will stop that nested loop execution, but continue with the outside one, which of course means that for the next iteration of the outside one, a new inside one is started, and that will then run. But the currently running inside nested loop will stop when you call break. If you call break in the outside loop, well then this outside loop is finished, and therefore there also will be no next run of the inside loop, because that only runs for every iteration of the outside loop. And since we break out of that and we finish that outside loop, there's no more inner loop execution too. So break stops the loop in which you call it. So in which you call it directly. So you have to not have it in a nested loop, but directly in that loop as we do it here. This break call here will stop this outer for-off loop. The result of that is that if we save that and we go back to our program, and I then attack and have a strong attack, and I then click show log, we only see one entry here. We see our attack. We don't see the attack by the monster. We don't see our strong attack or the response on that by the monster. We only see that very first event we wrote to the log, so that very first attack we launched. That's how break works. Now we could actually use that to make sure that whenever we press the show log button, we only output one event at a time, but of course not always the same one. That would be great. And for that, we can add a new global variable where we keep track of the last event we logged. So for that, I'll add a new variable up there, last logged event or last logged entry. And initially that's not even 0, that's -1 or just not defined, let's say. And then we can use the last logged entry down there in our loop where we log the entries to set last logged entry equal to I. So in this case to 0. Now we can add a if statement here and say if last logged entry is not set, so add an exclamation mark here. So if this is undefined or falsy at the beginning, which it is, or if last logged entry is set and it's equal to I, then I want to log my event. So we move that code into this if statement. And then, since we now logged something, we update the last logged entry to that I number. And thereafter, we increment I, and we break. This is still not the finished logic. Now, if I save that, and I go back to the web page, and I attack and strong attack, and I click show log, we see that entry. And if I click show log again, we see that same entry still. So we can add that same entry multiple times. So we haven't changed a lot here. The reason for that is that we set last logged entry here to I, so to 0 for the first run. And here we check if we have no last logged entry or if last logged entry is equal to I. But we always start at I0, so this is always true. And therefore we always log this. Now the trick is actually to change this here to look for last logged entry to be smaller than I. And if we do that and we go back to the page, I can click attack and strong attack and then show log, and we have one entry. But if I click it again, we still keep on printing results. The reason for that is that this change here will actually yield true if last logged entry is undefined, but also if it's 0, because as you learned, 0 is a falsy value. It's treated as false. So this here with the exclamation mark actually yields true and therefore executes this code if last logged entry is 0. So I'll combine this first condition here with another condition that last logged entry is not equal to 0. So if this is falsy, but it's also not falsy because it's equal to 0, or last logged entry simply is smaller than I, then we want to log something. So now with that, if we go back to the web page and we attack and strong attack and I click show log, we have an entry here. But if I click show log again, now you see I only print my stripes here, my dashes, but I don't print any real log entries anymore. And the reason for that is that we don't make it into the if block anymore. And that makes sense because I always starts at 0 when print log handler is executed, which is the case for every click. So that's not incremented across clicks. For every click, it restarts at 0. Last logged entry, however, does change with every click. It starts uninitialized, and then after the first log being printed, it is set to I, which is 0. So it's 0 after the first click. And thereafter, this code never runs again due to the logic we wrote here. So now the next step is to move break into this if statement so that the loop actually continues and has a chance of reaching a new I. So now if we save that, and we reload, and then we attack and strong attack, and now we click show log, we have that first event player attack with index 0. If I click show log again with index of 1, which is the monster attack. And now if I clear that, we can still continue pressing this button. Now we have some logic that allows us to log event by event with every new click until we have no more events, which is when we only print our dashes. Now, of course, you could add another if check here to make sure you don't execute any logic in here if we have a last logged entry that is greater than the length of our battle log in the end, which means we have no more entries. You could do that. So that's the break keyword. It allows us to break out of a function execution, for example, to do something like this, but you can do it for whatever reason you have in your code. It allows you to break out of a loop execution earlier than it normally would finish, so before the loop really finished. In this case, whenever we printed something to the console. But of course, you can use break for whatever reason you have. Doesn't have to be because you only want to log one thing at a time to a console. Could be any reason why you want to stop a loop iteration before it really is done. So that's break. Now I mentioned we also have another keyword, and that's the continue keyword. The continue keyword is a bit like break. It also stops the current execution of this code in your loop, but it doesn't stop the entire loop. So instead, it just moves on to the next iteration. I can best show how it works here in the console. If we add a quick for loop here, a normal for loop with I equal to 0, I smaller than 5, and I++, let's say, curly braces, and then shift enter to write some code between. And now, of course, if I console log I here, unsurprisingly, we print 0 to 4. Now press the up arrow to be able to edit this again. And now let's add a little if check in there where we check if I is equal to, let's say, 3, which is one of the values we're printing here. If that's the case, for whatever reason, I don't want to print it here. Well, then, of course, we could use break, right? This will stop the loop execution. If we hit enter, now we see 0, 1, 2, but we don't see 3, but also not 4, because we canceled function execution with break. This might or might not be what you want, because I actually only wanted to skip this 3 value. I didn't want to cancel the entire loop execution. And that's exactly what continue does. If you use continue instead of break, you just skip this loop iteration, so all the code after continue will not be executed, but for the next iteration it will continue as normal, so it will not break out of the loop, it just continues to the next execution. So if I now hit enter here, we see 0, 1, 2, 4, we don't see 3 because there we continue, and as I said, this means this code is skipped for this loop iteration. Subsequent iterations, like the 1, 4, 4, are executed. So break and continue give you some extra control over your loop execution. You definitely don't need them in every loop you write, but sometimes you have some code where you want to break out of a loop upon some condition being met, or you want to skip an iteration based on some condition, and then break and continue are your friends. Now there's one last feature related to break and continue, which I will be honest, you will very, very, very rarely need or use, but I still want to show it to you because it's part of JavaScript and you should learn it in this course, of course. And that's the so-called labeled statement. So let's say in this while loop, but again, this works in any loop, we have a nested loop. So we're logging j here, and then I have a for loop in there where I initialize, let's say, k to be 0. We could theoretically use I in here and it would create a new I detached from this I for this loop, but to avoid naming confusion, I'll use k in here. And k is maybe smaller than 5, that's our exit condition, and we increment k, and then I console log k here. So far that's nothing too fancy, we have a loop in a loop. If we now save that and we reload and we press log, maybe without doing anything before, we print 0, 1, 2, 3, 4. That's our nested loop in this outer loop. Now one tiny change, I'll set j to 0 here so that we run this outer loop more than once as well. So let me save that, reload, click show log. And now we have a lot of output here and we get that 0 here. Maybe to make it clearer what's coming from where, we can add outer as an identifier here and here inner. So I'll console log two things, an identifier and then the actual value, so that we can see which value is coming from where. And now we see we have the outer 0, then this inner loop completes, then the outer loop moves on to the next iteration, its second iteration, therefore we have a 1 there. We have a new inner loop starting at 0 again, all the way up to 4, a new outer loop iteration, a new inner loop, and so on. Now let's say you have some code, and typically of course you would not just be working with some numbers here, but you have some application, some other logic where you have some condition in your inner loop that should actually finish the outer loop. So for example here we could say if k is equal to 3, then that is a reason for us to stop the entire loop execution. Now, of course, we can do that with break, but what will actually happen here is that we just stop the inner loop, because as I mentioned, break will stop the nearest loop, so to say, the loop to which it belongs. So if I now reload here and we execute this code with show log, you see outer actually continues to work. We have outer 0, outer 1, and outer 2. And just the inner loop always stops after 2 because we break after a value of 3, or when k reaches a value of 3. Now what if we want to break the outer loop though? Well, you can do that with a so-called labeled statement. And that's really something, as I said, which you will rarely see and use in JavaScript. You can assign a name to this loop, and that again works on any loop. Actually, not just loops, you can assign it to any expression, but it really only makes sense on loops. You could name this outer while, so any name of your choice, and then you add a colon and then a white space. And now this is a name for the loop in front of which you added this. And you can add this, as I said, in front of any expression, but you typically do it in front of loops, because there you can use that because that is meant to be used with break and continue. You can also, but you don't have to, add this here in front of the for and maybe name it inner for. And now here you can use break like this to finish the inner loop, but if you want to finish the outer loop, now you can say break and then pass the name of the label you assigned to your outer loop. So in this case, outer while. And now this allows you to break a different loop than you're currently in. So now if we do that here, and I click show log, you see outer now actually finishes when inner reaches a value of 3, and we have no other outer logs. And you can do this not just from inside loops, but from anywhere in your code. So if you have an infinite loop running in one part of your code, and then you have another part in your code where you kind of react to a button click and that should stop that infinite loop, well, then you could also work with labeled statements and call break in one part of your code in your event listener to stop another loop where you assigned a label like this. So these are label statements and how you can use them. And you can not just use it with break, but if I comment this out, you can also use it with continue. Works in exactly the same way, just with the continue functionality, where we don't stop the loop, but only the current execution. And therefore here, in this case, we just continue with our outer loop. Though now I actually created an infinite loop here. So you will need to close that browser window here in this place. And I did create an infinite loop here because by continuing with the outer while, well, we never reach this J++ code here, right? We execute this outer loop, then we start with this inner loop right away. There, whenever we reach K, which we always will at some point of time, we continue with the outer loop. And therefore, this J++ part, which is important for our exit condition, will never run. So this actually is dangerous because we create an infinite loop here, as you just saw. So you should always watch out what you're doing with continue if you accidentally maybe create an infinite loop, which you probably don't want to do. So that's one thing. The key thing here are the label statements, though. The labels you assign here to your loops, which you can then use with break and continue. Again, nice to know, nice to understand if you encounter it in some examples or in an interview, but really a feature which you will rarely need, as you will see as you work with JavaScript. This is something that comes with experience, but there you will see that you really don't have a lot of occasions where you would need this. Still, since it's a part of the language, I didn't want to hide it from you. Now, after all these if statements and all these loops, I want to conclude this module by diving into error handling, another form of control structure you'll need in your JavaScript code to build code that runs under different and also under harder circumstances. And what do I mean by that? In the JavaScript applications, in the programs you're going to write, you can't always avoid all errors. Some errors can't be avoided. And with that, I of course mean errors that are beyond your control as a developer. So I'm not talking about bugs which you introduced into your code or about syntax errors. You should have a look at the debugging module in this course to learn how you can fix and avoid such errors. I am talking about errors which you can't rule out when you're writing your code. For example, user input errors, that a user enters text like hi in a field where you expect a number. Or network errors, that you're maybe communicating with some server, something we haven't done yet but which we'll do later down in the course, and that server is offline. Or something like that. So basically things where you have no chance of ruling out that this problem occurs because you can't control what a user types into the input field. You can do your best to kind of restrict the options the user has, but ultimately users might always find a way of breaking your code, so to say. And the same for network errors. You can't rule out that a server might be offline when you're trying to talk to it. So the best you can do in these cases is that you throw your own errors and catch errors to fail gracefully, which means maybe at least show the user a nice error message, or in the best possible case, maybe you can write some fallback code so that you can recover and you don't even need to show an error message to the user. And you can do that with try catch, another control structure which JavaScript exposes to you that allows you to try a certain code which might fail, and then catch potential errors thrown in that code to then do something with them, or to do something in the case that such an error occurred. Now back in our little project, the Monster Killer project, let's simulate such a problem. We do get some user input here actually. We get that entered value, and I already do some validation here. We check whether what the user entered can be used as a maximum life, so if it's bigger than 0, and if it is a number to begin with after converting it to a number. Now, the kind of sad thing here, in quotes, because it's actually good of course, is that parseInt doesn't throw an error if the user enters something invalid. In other programming languages that could be the case, But JavaScript is really forgiving here, and if you enter something that can't be converted to an integer or to a number here, well, then you don't get an error, you don't get a system error that crashes your script, but instead parseInt generates this NaN value, which we check for with isNaN. So this doesn't really produce an error, but here to continue and show you try catch, I want to have a real error. And the good thing is we can create and throw our own errors. And whilst it might sound strange that you want to do that in your code, you have to keep in mind that with JavaScript you can write very big applications spanning across multiple files, and indeed you might want to throw an error in some parts of your application so that you can use these official error management tools to handle that error instead of having to write a bunch of if statements in a couple of different places of your code. So especially in bigger applications, it's quite common that you throw your own errors in some parts of it. And here we will throw our own error so that we can practice with try catch. In other situations, which we'll see later in the course, for example, when communicating to a server, you will automatically get an error. So JavaScript or the browser will automatically throw an error if things go wrong. Here for this user input, this kind of unfortunately isn't the case, so we'll do it on our own. So how can we do it on our own? Well, let's first of all move this logic here where we get that entered value into a function. So I'll cut that and then maybe here add a new function, which I'll name get max life values. And in here I get that entered value and I try to parse it as an integer. And then here I'll take that if check and put it in here to validate what the user entered. But then here I'll not set chosen max life to 100 if this is not valid. Instead, I will change this to be a constant, which I'll name parsed value, something like this. We'll need that in a second. And then outside of that function here, I will add that chosen max life variable, which I'll for now set equal to get max life values. So I will call the function here, and in that function I want to return the parsed value here in the end. That's the idea. But in this if statement, if we have an invalid value, then I will not return 100 as a fallback value, which we of course could do. But in order to see how you handle errors, I will use another keyword in JavaScript, which is the throw keyword, which throws a new error. And an error can be anything. You can throw a number as an error, a string, or an object. And here I'll throw an object with a message property. That's kind of the convention. Most errors are objects that have a message property, where I say invalid user input, not a number, something like that. So now we throw our own error here. And the result of that is that if we go back to our application, and we open the developer tools here and I reload and I enter a valid value, then I got a different error, cannot access chosen max life before initialization. Yes, because here of course I should, in my if condition here, I should check parsed value, not chosen max life. Since I changed it here, we should change it here as well. So that was not what I wanted to show you. Let's reload. If I enter 100 instead, this works as before. But if we now reload and I enter a high there, which can't be converted to a number, we now get our own custom error thrown here. You see, this is just an error with which is our object in the end with that message. But it's marked as red because this indeed is now really an error. And it stops our script execution therefore. So pressing these buttons doesn't do anything. So we crashed our script. Again, you might want to do it on your own in more complex scripts so that you can use the error handling mechanism in different parts of it. Here, I'm mostly doing it so that we can now practice with try catch, because you will later also work with other things like network requests, where JavaScript itself will throw errors, and therefore you need to be prepared to handle such errors. So, how do we use try catch? Now, what about the while loop? I have no great place to squeeze it in here, though I will say you can also use a while loop to replace a for loop. So if we would want to replace this, we would have to manage the variable manually. Now, since I use I down there, I now have to use a different name because now we're initializing it in the function, and there we must only use each name once. So here I'll go with j, initialize this to be 0, and then we can add a while loop with the while keyword, then a condition between parentheses, and then your loop body. Now, if you put something like true here, this is obviously always true, and therefore this would give you an infinite loop, which you want to avoid because it will crash your application. Instead, here we could check if j is smaller than 3, and then here we can console log our code from up there, so these dashes here, and then simply increment j, and now we manually replicated this behavior. Though I will say, if that's what you want, you would go for the for loop. This is just so that we can have a first look at while. So if I reload, strong attack and show the log, we see our dashes here 3 times just as before. But again, you wouldn't really use while for that, you would go with the for loops. So let me quickly comment that back in and comment out the while loop. Now, a more realistic use case of such a while loop might be that you create some dynamic value in there and at some point of time you want to stop. Let's say you're generating random numbers, and I'm doing this here in the browser console, so I create my random numbers variable, and you have another variable finished, which initially is false. And then you write your while loop where you check for it not being finished, so with the exclamation mark, because this has to return true to make it into the body. And then you place your cursor between the curly braces, you hold shift and press enter. Now you can write multi-line code here, because pressing shift without enter executes the code. Don't do this yet, because then you'll have an infinite loop and you'll have to close your browser and reopen it to get back to work. So now we have the while loop, and in there I now generate a random number with math random. Haven't used that before, but this gives you a random number between 0 and 1. Again, hold shift, hit enter to enter a new line here. Add it to your random numbers here. So random numbers push, random number. And now let's say we're done in another new line with shift enter. If random number is greater than 0.5, which will take maybe just 1 try or 10 tries, it's random. So if random number is greater than 0.5, then again, curly brace, hold shift, hit enter. Then in here, I want to set finished to true, which means then this condition will no longer be true, and therefore we shouldn't execute this loop anymore. At this point of time, I then also want to console log my random numbers. So if you now hit enter, this executes, and you see here, it does execute for me with 4 numbers that are generated, and this was the number greater than 0.5, after which it finished. If I repeat this code by pressing the up arrow here, which quickly recreates the code we just wrote, so the up arrow key on your keyboard, and I hit enter, well, now it doesn't even execute because finished, of course, was set to false, to true. So let's set finished back to false here, actually. And then thereafter, by pressing the up arrow key multiple times, go back to the while loop, hit enter again. Now it took 5 tries. We have 5 elements here. Though that's not entirely correct. Of course, it used the old array and just added 1 element, so it actually took only 1 try. Let's do this again. Let's set finished to false, and let's also reset the random numbers array to be an empty array. And now repeat while. Now this took 2 tries here in my case. Of course, how many tries it takes will differ for you, but this is an example where you might use while because you don't know in advance when you will be done. You don't know how often this will need to run because the exit condition is derived inside of the loop code. Now there also is a variation of while, and that's do while. For that, I'm back in our code here, and I'll bring back this while loop with j, and there we created these 3 dashes. Now, if I log j instead, let's see what that yields. If I save that, open the console in the developer tools and reload the page, and then press show log, we see 0, 1, and 2. The same we earlier had for the for loop, which makes sense. We start at 0, check this condition, 0 is smaller than 3, so we print this, increment this, now we have 1, smaller than 3, we print this, increment this, now we have 2, smaller than 3, and for a third time we print this, the value currently is 2, which is the latest value, the most recent value we see here. We increment this, value now is free. This is not fitting our condition anymore, so we exit by that time. So this works as expected. Now let's say you actually always want to execute your loop body before the condition is checked, because at the moment the condition is checked before the loop body is executed, maybe you want to do it the other way around. Well, then you can use a do while loop. For that, you can cut your body here and then add the do keyword and add your body here. And then typically you move while right after the closing curly brace, though technically it also works if it's in a new line. What this does is it now executes the body first and thereafter checks the condition. If you now save that and you reload and you press show log, you see we print the same as before because we still exit after this is equal to free. But you'll notice a difference if you, for example, set j to free initially. If you do that with a do while loop and I reload here and show log, you still see free being printed here. Now if we go back to the other while loop without do, so by cutting this and removing the do keyword, if we do that here, then you will see that now actually, if I reload here and press show log, we don't see the free here. The reason for that is that free, of course, is not smaller than free, and here we check the condition first. But with do while, in which case, by the way, it's also common to add a semicolon after while, not a must do, but you typically do it in this notation, not after the normal while loop, but that's just a side note. But the important thing here is this code runs first and thereafter this is checked. So that's why we here see free being printed if we initialize j to be free, because this condition, which actually finds out that we don't want to continue for j being equal or greater than free, is only executed after we first ran this loop body. So that's while and do while. You typically will use for loops more often. While loops are kind of niche. There are some use cases where they're really great, but for the majority of use cases, you typically work with for and for off and for in loops. That just happens to be the case, the way we write programs and what we want to do in there. But it's good to have while loop, especially if you have some condition which changes inside of the loop and you don't know in advance how often you want to execute that loop. Then while loops can really shine. Now, to conclude that part about loops, I want to dive into two important keywords which can help you control your loop execution. And that's the break and the continue keyword. We saw the break keyword already in our switch statement. There we have break to avoid that fall through mechanism. We can also use break inside of loops to leave the loop execution, to stop the loop execution earlier than it normally would. So to kind of cancel the loop execution. How does that work? Now let's say we only want to output one log entry. Well, of course, there are various ways of achieving this, but one way would be to simply add a break keyword here. Maybe after this I++ thing. Doesn't really matter for this example, though. Now, what this will do is it will tell JavaScript, and it works in any loop, by the way, not just in for off loops, but in all loops I showed you. It tells JavaScript, stop this loop execution. Of the loop I'm calling this in. So if you're calling this in a nested loop, it will stop that nested loop execution, but continue with the outside one, which of course means that for the next iteration of the outside one, a new inside one is started, and that will then run. But the currently running inside nested loop will stop when you call break. If you call break in the outside loop, well then this outside loop is finished, and therefore there also will be no next run of the inside loop, because that only runs for every iteration of the outside loop. And since we break out of that and we finish that outside loop, there's no more inner loop execution too. So break stops the loop in which you call it. So in which you call it directly. So you have to not have it in a nested loop, but directly in that loop as we do it here. This break call here will stop this outer for off loop. The result of that is that if we save that and we go back to our program, and I then attack and have a strong attack, and I then click show log, we only see one entry here, we see our attack. We don't see the attack by the monster. We don't see our strong attack or the response on that by the monster. We only see that very first event we wrote to the log, so that very first attack we launched. That's how break works. Now we could actually use that to make sure that whenever we press the show log button, we only output one event at a time, but of course not always the same one. That would be great. And for that, we can add a new global variable where we keep track of the last event we logged. So for that, I'll add a new variable up there, last logged event or last logged entry. And initially that's not even 0, that's -1 or just not defined, let's say. And then we can use the last logged entry down there in our loop where we log the entries to set last logged entry equal to I. So in this case to 0. Now we can add a if statement here and say if last logged entry is not set, so add an exclamation mark here. So if this is undefined or falsy at the beginning, which it is, or if last logged entry is set and it's equal to I, then I want to log my event. So we move that code into this if statement. And then, since we now logged something, we update the last logged entry to that I number. And thereafter, we increment I and we break. This is still not the finished logic. Now, if I save that and I go back to the web page and I attack and strong attack and I click show log, we see that entry. And if I click show log again, we see that same entry still. So we can add that same entry multiple times. So we haven't changed a lot here. The reason for that is that we set last logged entry here to I, so to 0 for the first run. And here we check if we have no last logged entry or if last logged entry is equal to I. But we always start at I0, so this is always true. And therefore we always log this. Now the trick is actually to change this here to look for last logged entry to be smaller than I. And if we do that and we go back to the page, I can click attack and strong attack and then show log, and we have one entry. But if I click it again, we still keep on printing results. The reason for that is that this change here will actually yield true if last logged entry is undefined, but also if it's 0, because as you learned, 0 is a falsy value. It's treated as false. So this here, with the exclamation mark, actually yields true and therefore executes this code if last logged entry is 0. So I'll combine this first condition here with another condition that last logged entry is not equal to 0. So if this is falsy, but it's also not falsy because it's equal to 0, or last logged entry simply is smaller than I, then we want to log something. So now with that, if we go back to the web page, and we attack and strong attack, and I click show log, we have an entry here. But if I click show log again, now you see I only print my stripes here, my dashes, but I don't print any real log entries anymore. And the reason for that is that we don't make it into the if block anymore. And that makes sense, because I always starts at 0 when print log handler is executed, which is the case for every click. So that's not incremented across clicks. For every click, it restarts at 0. Last logged entry, however, does change with every click. It starts uninitialized, and then after the first log being printed, it is set to I, which is 0. So it's 0 after the first click. And thereafter, this code never runs again due to the logic we wrote here. So now the next step is to move break into this if statement so that the loop actually continues and has a chance of reaching a new I. So now if we save that, and we reload, and then we attack and strong attack, and now we click show log, we have that first event, player attack, with index 0. If I click show log again, with index of 1, which is the monster attack. And now if I clear that, we can still continue pressing this button. Now we have some logic that allows us to log event by event with every new click until we have no more events, which is when we only print our dashes. Now, of course, you could add another if check here to make sure you don't execute any logic in here if we have a last logged entry that is greater than the length of our battle log in the end, which means we have no more entries. You could do that. So that's the break keyword. It allows us to break out of a function execution, for example, to do something like this, but you can do it for whatever reason you have in your code. It allows you to break out of a loop execution earlier than it normally would finish, so before the loop really finished. In this case, whenever we printed something to the console. But of course, you can use break for whatever reason you have. Doesn't have to be because you only want to log one thing at a time to a console. Could be any reason why you want to stop a loop iteration before it really is done. So that's break. Now I mentioned we also have another keyword, and that's the continue keyword. Now there's one last feature related to break and continue, which I will be honest, you will very, very, very rarely need or use, but I still want to show it to you because it's part of JavaScript and you should learn it in this course, of course. And that's the so-called labeled statement. So let's say in this while loop, but again, this works in any loop, we have a nested loop. So we're logging j here, and then I have a for loop in there where I initialize, let's say, k to be 0. We could theoretically use I in here, and it would create a new I detached from this I for this loop, but to avoid naming confusion, I'll use k in here. And k is maybe smaller than 5, that's our exit condition, and we increment k, and then I console log k here. So far that's nothing too fancy. We have a loop in a loop. If we now save that and we reload and we press log, maybe without doing anything before, we print 0, 1, 2, 3, 4. That's our nested loop in this outer loop. Now one tiny change, I'll set j to 0 here so that we run this outer loop more than once as well. So let me save that, reload, click show log. And now we have a lot of output here, and we get that 0 here. Maybe to make it clearer what's coming from where, we can add outer as an identifier here, and here inner. So I'll console log two things, an identifier and then the actual value, so that we can see which value is coming from where. And now we see we have the outer 0, then this inner loop completes, then the outer loop moves on to the next iteration, its second iteration, therefore we have a 1 there. We have a new inner loop starting at 0 again, all the way up to 4, a new outer loop iteration, a new inner loop, and so on. Now let's say you have some code, and typically of course you would not just be working with some numbers here, but you have some application, some other logic where you have some condition in your inner loop that should actually finish the outer loop. So for example here we could say if k is equal to 3, then that is a reason for us to stop the entire loop execution. Now, of course, we can do that with break, but what will actually happen here is that we just stop the inner loop, because as I mentioned, break will stop the nearest loop, so to say, the loop to which it belongs. So if I now reload here and we execute this code with show log, you see outer actually continues to work. We have outer 0, outer 1, and outer 2. And just the inner loop always stops after 2 because we break after a value of 3, or when k reaches a value of 3. Now what if we want to break the outer loop though? Well, you can do that with a so-called labeled statement. And that's really something, as I said, which you will rarely see and use in JavaScript. You can assign a name to this loop, and that again works on any loop. Actually, not just loops, you can assign it to any expression, but it really only makes sense on loops. You could name this outer while, so any name of your choice, and then you add a colon and then a white space. And now this is a name for the loop in front of which you added this. And you can add this, as I said, in front of any expression, but you typically do it in front of loops, because there you can use that because that is meant to be used with break and continue. You can also, but you don't have to, add this here in front of that 4 and maybe name it inner 4. And now here you can use break like this to finish the inner loop, but if you want to finish the outer loop, now you can say break and then pass the name of the label you assigned to your outer loop. So in this case, outer while. And now this allows you to break a different loop than you're currently in. So now if we do that here, and I click show log, you see outer now actually finishes when inner reaches a value of 3, and we have no other outer logs. And you can do this not just from inside loops, but from anywhere in your code. So if you have an infinite loop running in one part of your code, and then you have another part in your code where you kind of react to a button click and that should stop that infinite loop, well, then you could also work with label statements and call break in one part of your code in your event listener to stop another loop where you assigned a label like this. So these are label statements and how you can use them. And you can not just use it with break, but if I comment this out, you can also use it with continue. Works in exactly the same way, just with the continue functionality, where we don't stop the loop, but only the current execution. And therefore here, in this case, we just continue with our outer loop. Though now I actually created an infinite loop here. So you will need to close that browser window here in this place. And I did create an infinite loop here because by continuing with the outer while, well, we never reach this J++ code here, right? We execute this outer loop, then we start with this inner loop right away. There, whenever we reach K, which we always will at some point of time, we continue with the outer loop. And therefore, this J++ part, which is important for our exit condition, will never run. So this actually is dangerous because we create an infinite loop here, as you just saw. So you should always watch out what you're doing with continue if you accidentally maybe create an infinite loop, which you probably don't want to do. So that's one thing. The key thing here are the label statements, though. The labels you assign here to your loops, which you can then use with break and continue. Again, nice to know, nice to understand if you encounter it in some examples or in an interview, but really a feature which you will rarely need, as you will see as you work with JavaScript. This is something that comes with experience, but there you will see that you really don't have a lot of occasions where you would need this. Still, since it's a part of the language, I didn't want to hide it from you. Now back in our little project, the Monster Killer project, let's simulate such a problem. We do get some user input here actually. We get that entered value, and I already do some validation here. We check whether what the user entered can be used as a maximum life. So if it's bigger than 0 and if it is a number to begin with after converting it to a number. Now, the kind of sad thing here, in quotes, because it's actually good, of course, is that parseInt doesn't throw an error if the user enters something invalid. In other programming languages, that could be the case, but JavaScript is really forgiving here. And if you enter something that can't be converted to an integer or to a number here, well, then you don't get an error, you don't get a system error that crashes your script, but instead parseInt generates this NaN value, which we check for with isNaN. So this doesn't really produce an error, but here to continue and show you try catch, I want to have a real error. And the good thing is we can create and throw our own errors. And whilst it might sound strange that you want to do that in your code, you have to keep in mind that with JavaScript, you can write very big applications spanning across multiple files. And indeed, you might want to throw an error in some parts of your application so that you can use these official error management tools to handle that error instead of having to write a bunch of if statements in a couple of different places of your code. So especially in bigger applications, it's quite common that you throw your own errors in some parts of it. And here we will throw our own error so that we can practice with try catch. In other situations, which we'll see later in the course, for example, when communicating to a server, you will automatically get an error. So JavaScript or the browser will automatically throw an error if things go wrong. Here for this user input, this kind of unfortunately isn't the case, so we'll do it on our own. So how can we do it on our own? Well, let's first of all move this logic here where we get that entered value into a function. So I'll cut that and then maybe here add a new function, which I'll name get max life values. And in here, I get that entered value and I try to parse it as an integer. And then here, I'll take that if check and put it in here to validate what the user entered. But then here, I'll not set chosen max life to 100 if this is not valid. Instead, I will change this to be a constant, which I'll name parsed value, something like this. We'll need that in a second. And then outside of that function here, I will add that chosen max life variable, which I'll for now set equal to get max life values. So I will call the function here. And in that function, I want to return the parsed value here in the end. That's the idea. But in this if statement, if we have an invalid value, then I will not return 100 as a fallback value, which we of course could do. But in order to see how you handle errors, I will use another keyword in JavaScript, which is the throw keyword, which throws a new error. And an error can be anything. You can throw a number as an error, a string, or an object. And here I'll throw an object with a message property. That's kind of the convention. Most errors are objects that have a message property, where I say invalid user input, not a number, something like that. So now we throw our own error here. And the result of that is that if we go back to our application and we open the developer tools here and I reload and I enter a valid value, then I got a different error, cannot access chosen max life before initialization. Yes, because here, of course, I should, in my if condition here, I should check parsed value, not chosen max life. Since I changed it here, we should change it here as well. So that was not what I wanted to show you. Let's reload. If I enter 100 instead, this works as before. But if we now reload and I enter a high there, which can't be converted to a number, we now get our own custom error thrown here. You see, this is just an error with which is our object in the end with that message. But it's marked as red because this indeed is now really an error, and it stops our script execution therefore. So pressing these buttons doesn't do anything. So we crashed our script. Again, you might want to do that on your own in more complex scripts so that you can use the error handling mechanism in different parts of it. Here, I'm mostly doing it so that we can now practice with try catch, because you will later also work with other things like network requests, where JavaScript itself will throw errors, and therefore you need to be prepared to handle such errors. So, how do we use try catch? The idea is that you wrap try catch around the code that might fail. So you might think, great, I'm going to put my entire program into the try block, right? We put all that code here, all of that, we move that into try, because then we catch any error that might occur. And even though we don't know yet what we can do then, this sounds good. We catch any error and we'll probably be able to do something great and have our script not fail. This is not what you should do. Don't wrap your entire script into try. It's not good for performance, and it's also a very bad programming style. You want to write code that doesn't yield errors, and you can use the debugging section to find and fix logical and syntax errors. You only want to move code into try where you can't control whether it throws an error or not. As it's the case here, we can't control whether the user enters something valid or not. So in the end, we move this line in here, but since I want to be able to use chosen life thereafter, I will actually create and declare the variable before the try block like this, and then only assign a new value to it inside of the try block. So now we have that try block which tries that code, but just like that, it's not valid, it's not helpful, and it's also not valid syntax. You also need to add a catch block. So you add the catch keyword, and then you add parentheses, and in there a parameter, which you can give any name you want. Typically you name it error. This now is like a function, so you add curly braces thereafter, and inside of these curly braces, this error which was caught is available. So this is called like a function by JavaScript, and error is the error which was thrown. In this case, it's your own error object. If it's some system error, like with the network request I already mentioned, then it will be that error object which JavaScript created for you. So here, for example, we can now console log that error to have a look at it to see what's inside. And we could now say, okay, chosen max life in this case is 100. That's our fallback logic. If this fails, and if it succeeds, by the way, of course, this will not execute. But if this fails, if we get an error here, then this will not execute successfully, but this here will. And therefore here we can now set a value with which the rest of our code works. This is not always possible. Sometimes the best you can do is show an error message to the user. For example, if a server is offline and you can't save data on a server, there's little else you can do. You can just tell the user about that and tell him to not leave the page and try again later. In other cases like this, you might be able to use a fallback value and fall back without the user even noticing. You could, of course, also tell the user that you entered something wrong. Default value of 100 was used, so that you fall back, but you let the user know about that. That's totally up to you. So now with that, if we save that and we reload, now if I enter hi there, I get that you entered something wrong. I get that console log, which, please note, now is not an error anymore. We don't have that red background, so this is not a system error anymore. Instead, it's just a normal log message. And our app works just as before with that value of 100 being used. So that now all works, and we can play with this game just as before, but now with our own error handling logic. In this case, with a graceful fallback. In other cases, showing an error message might be the best you can do. Now, just to make this really clear again, of course, the logic we had before, where we had just this if check and then also assigned a default value of 100, wasn't bad. I wanted to show you try catch, which here isn't bad, and in other cases is absolutely necessary, because in other cases you get an error if you want it or not, and you need to be able to handle it. That's why it's a good time to already practice with it here, even though in this exact case, since parseInt doesn't throw an error, you could have absolutely kept the old logic and avoided this try catch block. Now, I'm not entirely done with try catch. You can also add another element to try catch, and that's finally. Now, you add finally like this. You add the finally keyword after try or after try catch. You don't need to have catch. You can just have finally here. You need to have try though. Try catch without try doesn't exist. But you can also have try catch finally. And the idea is that the code inside of finally will now always execute no matter if you had an error or not. Now you might wonder what the idea behind that is, because the code after try catch, so all the other code, also executes here no matter if we had an error or not. So why would this be helpful? Well, you can use finally to do any cleanup work if you, for example, have a case where another error happens inside your try catch block. And be that only because you maybe throw the error again. That's also something you will sometimes do the more advanced you become. This is called rethrowing an error, and we might do some error handling here, typically not some fallback as we're doing it here though, but we might just be sending that error to our own analytics server, for example, so that we are notified of that error we had in our application. Maybe we can't fall back as we can here, but maybe we can just show the user an error message, and we also want to log the error to our own analytics servers. So we might be sending that request to our own servers here, and then we rethrow that error. We rethrow that error here so that in some other part of our code, we can then handle it and show that error message to the user. Again, that's a little hard to imagine here. I'm aware of that because this is some basic project, some basic program, but you could have multiple try-catch blocks in different places of your app. And here you only have the first one, which sends it to your own servers, and then you throw that error again. Now, in that case, still maybe you want to do some cleanup work here. Maybe release some data which you saved, maybe clear some variables. Do something like this, and then you could do that in finally. Now, I will be honest, in a lot of scenarios, you will not need finally. Especially in this example, you definitely don't need it because we can perfectly fall back. So the code after this will execute. There's no reason to rethrow the error. If you would rethrow, the code thereafter doesn't execute and only finally will. That's the difference then. That's the advantage of finally. It executes even if you do throw an error here. The other code will not because your script will crash if you then don't handle it somewhere else. But here we don't really need that because we have a perfect fallback. It's good to know that finally is there though in cases where you will have an error in catch, you rethrow or you get another error and therefore you know the rest of your script will not be able to continue. Well, then finally can be used for some cleanup work and that can be helpful at times. Now, just as with the other constructs shown here, we'll also see try catch in action again later in the course, and especially when we work with network requests, it will make more sense because then we really need it, then there are things we can't do without it. But since it is a control structure, now is the time to introduce it, keep it in mind, keep its general functionality in mind, that you try code and then you can react upon an error and fall back or show an error message, and you'll get more and more practice with it throughout this course. So that was a really long module, a long course section, because control structures are such a key feature in any programming language, and therefore, of course, also in JavaScript. You learned a lot about if and else if, about these logical operators, equal, triple equal, smaller than, smaller or equal, greater than, and so on. You learned how to combine conditions with and also with or, of course, which we had here, for example. You also learned about the special behaviors of and or, which you can use to assign default values or to assign certain values if some other condition is true. You learned about booleans, true and false, and also about falsy and truthy values, and that JavaScript, if no logical operator is given, tries to coerce a value that is not a boolean to a boolean value. And you learned about some of the rules, like 0 being treated as false, any other number, including negative numbers, being treated as true, and so on. That's also important, of course. You learned about the ternary expression, which allows you to write inline if statements, so to say, which you can't do with normal if statements. But if you just need a value and you have a relatively short condition and a relatively short code to get that value, then this can be an alternative to writing a more verbose if statement where you assign values to variables. And you also learned a lot about loops, about the different loops that exist in JavaScript, how they generally work, how you work with them, how you configure them. And there, of course, you also should play around with these to get a feeling for how they behave, how you can configure them, and how you can use them. And it's needless to say that throughout this course, we will heavily work with if and with loops, of course. These are core constructs of any programming language and therefore also of JavaScript. We also had a look at error handling in this module, another crucial concept which will be important in more complex programs you're going to write, which will also be important later down in the course, and which also is a control structure because it allows you to control code that might fail and then act upon an error and do some fallback logic, show an error message to the user, things like that. And besides this little project we worked on, where I can only encourage you to dive into the code, tweak certain things, and fully understand how it works and what we did there, besides that, I do encourage you to play around with these things on your own. Also, of course, use the resources you find in this module, like the attached slides. And if this is very much right now, which it certainly is, don't feel overwhelmed. These are core constructs and therefore we will use them throughout the entire rest of the course. So if you're not entirely sure yet when you would use which loop, you will get a lot of practice just by continuing with the course, of course. Because we will use loops there, we will use if statements there, we will use many logical operators there, and therefore all these concepts here will come to life over and over again throughout this course.